Hi folks, my name is Paul Hudson and I run a site called Hacking with Swift. Hopefully you can all see and hear me correctly. This is being recorded live on YouTube. If you can't, please now complain in the comments as fast as you can. Otherwise, I'll be talking to myself for the next hour and a half, 2 hours. We'll see how we get on. Say hello in the comments if you are watching. The goal for this video is to create a complete iOS app using SwiftUI from scratch as we go live here on YouTube. And by itself, that's nothing particularly special. You know, we all make SwiftUI apps all the time, and there's lots of them on YouTube. But there are, I think, a few things that make this one particularly interesting and useful. One of which is, first, my dogs will turn up randomly. As you can see, my dogs love coming in, those treats all the time when they turn up on my place. But second up, more importantly, this is aimed specifically at beginners. So absolute or very, very near beginners will get a lot from this video because we're going to walk through the basics of SwiftUI and also, hello dogs, and also of Swift. So there's lots of things we'll be digging into here very, very carefully as we progress our way through. And you're going to see me build the whole thing live. Like I said, it is live on YouTube, which is great because it means folks who are here in the chat will get to ask questions about why I've done certain things or how certain things work or what they mean or whatever. And that's great because hopefully someone watching later on, like you, hello, later on person, will have the same kinds of questions. And they'll be asking questions on behalf of you, which is great. David Papez, thank you so much for donating. Please don't give money to me here. This is a charity stream. There's a link you can post your money to, and it goes to the charity, not to me. So the link for the charity is for folks who want to donate to the charity, which is entirely optional, is there. It's in the video description as well, but that's the link for folks in the chat. Anyway, so when we're walking through building SwiftUI live here on YouTube, folks will ask questions. And this is actually, I said, a charity stream. I'm doing it on my birthday specifically because I want to raise money for a charity called Julian House, which is a local in my city here in the UK. And they work with vulnerable and at-risk people to help them if they have experienced homelessness or domestic abuse, or they need help leaving prison, or they have learning difficulties and more. There are lots of things they help with, and that's where your money goes if you donate to the charity. So please consider donating if you can. It'd be awesome to do that. And I want to show you before we start what we're actually going to be building so you can see what the plan is. Once I get my dog back out of the room again, we're actually going to be building this thing first. Chris Shah says, it is only for beginners. Yes, it's specifically for beginners. I've aimed this thing teaching you Swift and SwiftUI from scratch. No knowledge required right there. Anyway, I'll show you what we've built so far. It is this app here, Trekker, which was, of course, T-R-E-K-R, named after Flickr. It's obviously cool these days to avoid having vowels when they aren't needed. Anyway, Trekker. And it's going to show you a place you can visit like the Highlands in the UK. Has some travel advisories here if we have time to do that. You can read about it here. Then go to locations and see a map of places you can go and visit around the world. And you can tap one of these places here to find out more about it. For example, here I can press Japan and read about Kyoto. And there's a whole tips section as well, so you can learn more about traveling with this company, Trekker. This is the app we're going to make from scratch with no SwiftUI knowledge. That's the plan. So there's lots and lots to get through as we progress. I'll be answering as many questions as I can. Please try and keep them vaguely on topic. It's hard to jump around too much. Hashmi Dev asks, will it be available afterwards? Yes, it will. Hello, everyone watching tomorrow. I hope things are better in 2021 than they are in 2020. Anyway, that's what we're going to build. If you're here live, go ahead and ask questions. And there's one more thing which makes the stream very special, I think. Along the way, as you're watching, I'm going to be giving you quizzes. We're going to pause and give you a quiz based on what we've learned so far to test your knowledge, to make sure you actually are definitely listening and definitely following along. And so allow me to say, which of these things are correct. And if you are watching live, I ask you, please, please do not answer the quiz questions straight away. Give it time for folks watching later on to think about it, answer the questions themselves to make sure they are learning as well. And so please don't just dive in with the correct answer in the chat or even a wrong answer if you think it's hilarious. Do neither of those things, please. Give folks who are watching later the chance to think about the quiz questions themselves. Hopefully that's all clear. There are some moderators around. I saw Prathamesh commenting earlier, I have zero tolerance for abuse, harassment, that kind of thing. You'll get banned immediately. He's heavy with a ban hammer. So am I. Please be nice. That's our only request we're going to have in this entire video. Okay, that's enough fluff from me. Sai, thank you so much. You need to use a Just Giving link to give money to the charity. That's very generous, Sai. It's going to buy me a lot of dog treats. I would love if that money went to the charity instead, if possible. And you want to use the Just Giving link I've pasted earlier. I can paste it again, or someone else can paste it again into the chat for me. Please give money to the charity on there. That's why I'm doing this stream. Okay, enough chat. Let's get started with some code. Once I give my dogs another treat each, because they're obviously very, very hungry today. Come on, dogs. Up you come. 1, 2, right. That's your lot. Out. Clear off. Out. And out. Okay. Boom. Yeah, Krish, I have dogs, and they love being a star of the show. They really do love being a star of the show. They are terrible. Anyway. In Xcode, you can see here I have Xcode 12.3, which is the current latest version of Xcode from Apple. This will also work fine with 12.2 or 12.1 or even 12.0. It should work great in Xcode 13 and beyond as well. But you'll need at least Xcode 12.3. If you have not already got this, if you're a complete beginner, you can grab Xcode from the Mac App Store. It's free from Apple. Just go to the App Store on your Mac, and when it loads eventually, because it's obviously lightning fast, search in here for Xcode, Apple's software for making apps. And in here, you'll see Xcode. Go ahead and download that. It is free of charge to download. It is very, very big. It is a huge download, 11.6 gigabytes, and that's just to download it, never mind installing the damn thing. So give it time to download, and you'll have to pause the video and come back later on, perhaps. Go ahead and do that now. Okay, let's go ahead and dive into some actual work here, because I want to show you how we're going to use Xcode to build something real. You can see here I have Xcode already. Here, I'm going to go ahead and make a new project in Xcode so we can get started making something real. And that means pressing this button here, create a new Xcode project. Prathamesh, thank you so much for posting that link. If you could post that one regularly, it'd be great. I want folks to donate to the charity right there. It'd be really, really awesome. Thank you so much, folks. Anyway, create a new Xcode project, and I'll ask you which template do you want for your project. And there are some tabs across the top here asking you which platform you want to target. Because Swift, the language, and SwiftUI, the framework we're using, work on iOS and macOS and watchOS and tvOS, and Swift itself works on other platforms like Linux and Windows. But SwiftUI works on those 4, as well as multi-platform. I want to do multiple platforms at the same time. Here, though, we're going to keep it easy. Keep it nice and simple. I want you to choose just iOS for your template platform and choose app for the application. That gives you the most simple sort of skeleton template possible to get your app up and running. The absolute simplest version of your code. Now press Next. It's going to ask you what you want to call your product. What's your app's actual name? In our case, that is Trekker. Trekker. That's the name of our app. You can call it whatever you want. It's your app. You're following along. Do whatever you want to call your project. It's down to you. Below that, you'll see team. My team is Paul Hudson because I have an Apple developer account already. If you haven't got one, you want a free version of Xcode, of course you can have that just fine. Just change team to be none. It might already be that for you automatically. The organization identifier identifies your company uniquely. Who you are on the App Store. All your apps belong to the same company. For me, it is Hacking with Swift, my website. Behind me, right? And as a result, you use reverse domain name, hackingwithswift.com becomes com.hackingwithswift. Let's make sure your apps are unique on the App Store, because no one else has gone ahead and say Hacking with Swift is their brand. They're not. They're going to use their website, com. Who knows what or whatever, right? And what will happen is Xcode will take your product name, Trekker, plus your organization identifier and make what's called a bundle identifier here, which you can see in gray is com.hackingwithswift.trekker. That is a unique identifier for our app in the whole App Store. No one else can use that same ID. It's unique to us. And this means, this app downloads our data in iCloud, wherever it is, only belongs to us. If you want to have, com.apple.keynote, unsurprisingly, that's taken by Apple. That's Apple's keynote probably on the App Store. But this one, com.hackingwithswift.trekker, belongs to me in this app. You want to use something else, com.yoursite.yourappname. Something else here unique to you. For interface, make sure you choose SwiftUI. And lifecycle, please choose SwiftUI app. There are other options in there you could choose using Apple's older frameworks. But if you do that, you'll find the whole rest of this video deeply confusing. So please don't do that. Make sure you have SwiftUI and SwiftUI app selected here, and of course language Swift. Otherwise, you'll be totally baffled by what you see. There are some checkboxes. Please uncheck both of them, exactly as I have right here. Okay, once you're done, press Next, and then save it somewhere you want. In my case, I'll put it on the desktop. Boom. So it's made for me a new project called Trekker on my desktop. I can then put that into GitHub or somewhere else, or copy it around and share it with other folks if I want to. All my code for that project is now on my desktop. On the other desktop side, I've got two windows. It's on there somewhere in a folder called Trekker for me to use. Okay. Xcode creates for us in our simple skeleton project a few files. Over here on the left, and this is the project navigator over here. I make this window a bit bigger, take up all the space we can, I think. Let's go to the top of the window like that, and then bring it down like this. Boom. Okay. We've got a lot of stuff going on here. I prefer that window on the side actually, so let's make that, there we go, boom. All these files here, there's 4 of them by default, are created for us by that default Xcode template for us to work with and customize and add things to, or whatever we want to. And what you're seeing right now is there are 2 Swift files, trekkerapp.swift and contentview.swift. These are both files containing Swift code that we can customize, we can add more to it, we can do more with it. Giant wow, I have to have the chat on the screen, otherwise I can't see what you folks are saying, sadly. And if someone were to step out of the line, I can kick them off from that window on the side. Can I make it smaller though? No, I can't. That's as small as it goes. Cool. Sorry about that. I can get this bar on the side though. There you go. That can go away. Okay. So we have these 2 files, trekkerapp.swift and contentview.swift. The first of these is what starts our application to show some initial user interface on the screen. And the second, contentview.swift, is what gets shown. This is our first piece of UI, show this thing. And right now you can see content view shows the text, hello world. It's a pretty simple UI. And what you're seeing here is Swift code. This is just live Swift code right now. Of course, there are many other languages out there, like JavaScript, C++, Python, and more. But when you're building for Apple's platforms, Swift is by far the most popular. It is overwhelmingly the most popular language used for building Apple's platforms. Now, a question some folks ask when they're learning for the very first time is, what's the difference between Swift and SwiftUI? Well, Swift is what you're seeing right now. You're seeing the language itself, the words here, struct, var, body, sum view. This is Swift code right here happening right now. It's all the language itself. SwiftUI is a massive chunk of code written by Apple, mostly in Swift, that provides all the built-in behaviors we need to make our user interfaces. Things like text, things like shapes and colors and buttons and sliders and so forth. That is written in Swift, mostly, not entirely, but mostly in Swift. The SwiftUI is the toolkit that lets us build great UIs using Swift. Think of Swift as like English, and SwiftUI as being a book. Great expectations, right? The book is written using English. Anyway, I'm going to be explaining what this code does and what trekkerapp.swift does as we go, rather than going into it all up front, because that's quite boring. What I want to do instead is get right into seeing how this thing actually works. And you'll see on my screen, I've got this code on the left here. On the far left is my project navigator. And on the right, this is sort of gray stripy area. This is a preview canvas, which will show me my SwiftUI code as I am typing. And you'll see it says it's currently paused. But this button here, resume, will tell Xcode, hey, I want you to start looking at my code. So I'll press that now. And it'll have a good old think. It takes a little while the first time you do this thing. It'll build my code, it'll prepare the preview, and eventually, after a little bit of time, it'll show the preview on my screen. It's thinking right now, as you can see. Like I said, it is a bit slow at first, but it'll get there. Jorge, thank you so much. That's very generous for dog treats. If you want to give to the charity, please use the charity donation link. That'd be really, really appreciated. Anyway, boom. There is our SwiftUI preview. I can see Hello World right there. And this is basically emulating an iPod Touch 7th generation. I know it's that because up here it says iPod Touch 7th generation. I personally use an iPhone 12 Pro Max over here. And so I would much rather have my preview match my phone so I can see what I'm working with on a real device. And so I'll change this option here from iPod Touch to be iPhone 12 Pro Max. Again, it'll have a little think. Eventually it'll pop in with a 12 Pro Max size device. As you can see, it's a bit bigger. And it's still loading. Trust me, once it's loaded, it's really, really fast. Just the initial load is a bit slow. It's thinking now. Come on, you can do it. Ankit asks, is this stream for folks with zero experience in SwiftUI? Yes. You need zero SwiftUI to follow along, zero Swift, zero anything to follow along. Okay, and now we see Hello World inside our 12 Pro Max simulator, like that. Beautiful. Okay, I'm going to get this thing to take a bit less space up because there's a lot of space being chewed up by that right now. Might even zoom out slightly, make it a bit smaller. There we go. Okay, so there is our example output right now. And this is really cool because as you change your Swift code, if I had like goodbye world, boom, it pops in, goodbye world. You can see immediately what your actual SwiftUI code looks like. So it's a really fast way to preview. And a lot of folks use this very, very heavily. They design almost all their apps using just the preview because it's so fast to update. Often when I'm working myself, I prefer to run my code and see it actually running in a real app. But the preview does work very, very well most of the time. What you'll find is if you make a mistake, or certainly a series of mistakes, the preview will pause again. And you'll click resume, 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 again, 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 again. That'll happen a lot. It just will. You're learning to make mistakes all the time. You have to click resume a lot. And so a really important shortcut is Option Command P. Option Command P. Press that shortcut and it'll be resume. It presses the resume button for you. So you can resume as fast as you want to, as often as you want to. It's a good idea to know that one shortcut. Okay, so now you can see our app right there in the preview window. But that's the preview. It's not the real code actually running on a simulated device, just there in a little window, part of it. What I want to do is see this running on an actual device. And we can pretend a device by pressing Command R in Xcode. That will build our code. It'll convert it into code that a virtual iPhone here on my Mac right now can understand. And it will then run that code in the virtual iPhone. That's happening right now. Here is the iPhone 12 Pro Max simulator. This is simulating a real-ish iPhone 12 Pro Max with Goodbye World on. This is real. I can press, device, home. And now I'm on the home screen. I can swipe around, go to settings, swipe up here and do whatever. Look around in here. This is an actual virtual iOS device for us to work with. And it's really cool because you can now see what happens if I go to landscape mode. You press Command right, you're in landscape mode. So you can see it rotates smoothly. That's how your device, your app looks in landscape mode. So you can really interact with it like it was running on a real device, which is really, really nice. So I use the simulator a lot when I'm building. The preview is good for a quick test run, but the simulator is where it's at to really see how your code actually works. And now it's running for real, which is great. Now, obviously, this is not a terribly interesting app, right? The text hello world or goodbye world, meh, that's useless. What you want to do is add some real meaningful assets to your application. And I've provided some for you. They are in the description for this video. If you're watching live, I'll paste the link into the chat window for you. Like that. Boom. That link there should download for you. Boom. A file. And, all being well, you'll get a directory like this. There we go. Lucifero, I'm just going to go ahead and block you from the channel. Just get out. Honestly, I haven't got patience for it. Hide user on channel. Goodbye. You can just go away. You'll get assets like that on your zip file downloaded from my site. This contains a bunch of stuff you to work with in your application we're going to use in our program now. There are 2 JSON files here, plus a directory full of pictures. And we'll use most of these in our application here. And you should see the same stuff in your zip file all being well, if you have downloaded it now. JSON, if you aren't aware, is a very common file format. It comes originally from the JavaScript world. That's what the JS stands for. JS, JavaScript, it actually stands for JS Object Notation. That's what it is, JSON. And this is a very common way for sending data around between devices. For example, websites will often send JSON to web browsers, or server to server, or vice versa, or apps reader, or who knows what. JSON's very, very common way of storing data and sending it around. In the pictures directory are loads of images we'll be using in our program just shortly. But first things first, I want to look at this JSON file, because this thing is some information we'll be using in our application to build our app. Now, what I want you to do is select both these JSON files, locations.json and tips.json, and drag them from your Finder window into your project navigator. And see this little line appears below info plist. You can put it there if you want to, or put it above or here. Doesn't really matter. The little line means add these files there. So drag them into the navigator, and this window will appear saying, what do you want to do with them? As you can see, I've selected copy items if needed, create groups, and check the box for tracker. So this means copy these JSON files from my asset catalog into my project and add them to my program, like this. Having sound issues. Uh-oh. Yours is still loading. Okay. Hopefully no problems. Okay, phew, no problems there. Phew. That'd be a disaster. Anyway, copy the items and select tracker like that, and then go ahead and press finish. And it'll copy those JSON files into our project. What we've done is we've added them to our app bundle. Now, an app bundle is a combination of everything required to make our app actually work on someone's program. That means the finished compiled program itself, all our Swift code built for the application. It'll include our JSON files, any pictures, any audio, any movies, any kind of assets required to actually make our application run on a device. That's what's happening here. Speaking of pictures, we do have this whole pictures directory full of pictures. But I don't want you to drag them into the project navigator. Don't do that, because Xcode handles images specially. It actually performs, when you build your program, it performs a special pass on images to optimize them, to make them load faster, to make them take up less memory. And it's a good idea to let Xcode do that pass for us to make our code more efficient. And it's actually handled by this special file right here, assets.xc assets. This is an asset catalog. As that, if you repeat your comment once again, I will just ban you from the channel, or Prathamesh will. Assets.xc assets. This is an asset catalog, and you can store many kinds of things in here, like images, like colors, or PDFs, or 3D graphics, and more can go in here. And Xcode will take care of them. It'll optimize them for our program to be very, very efficient. Oh, Freddie, thank you so much. There is a charity link to use, folks. If you want to donate money, it's very kind of you. Please use the charity link if you'd be so kind. Anyway, this is an asset catalog. What I want you to do in Finder is go ahead and select all the pictures in this pictures directory you downloaded, every one of them, and drag them into the asset catalog right here below where it says accent color and app icon. Drag them into there, please. Boom. And it'll copy them all into our app bundle inside the asset catalog right here for us to use. Now, what's happening here is you might see This one here is at 2x. This is 3x. This is 3x, 3x, 2x, 3x. There are lots of 2x's and 3x's happening here, and no 1x's. What you're seeing here is a little bit of iOS magic. If you include the same image at different sizes, like small, medium, and large, with the same name, iOS will load the correct one at runtime when your program runs for the current device. Because some devices, like my iPhone 12 Pro Max, have super high-res screens. What they call it? It's like Super Liquid Retina HD Plus XDR, I don't know, mega display, right? That have really high-res screens, and they want to have the 3x images, super big images on the screen. Whereas older devices or less expensive devices have 2x screens, slightly lower resolution. And so you want to include multiple versions of the same file. And what will happen is they'll all go into a finished program. They'll all go to the App Store. And when someone downloads your application, the App Store will say, you are on a 3x device. I'll give you all the 3x assets. Or hey, you're on a 2x device. I'll give you all the 2x assets. So they'll get the correct set of assets for them. It's very, very optimized. It's called app thinning behind the scenes. It does a lot of work for us. So it's a very, very efficient way of working. Anyway, we just added a bunch of images to our project. Let's go ahead and try it out in Content View up here. So we have goodbye world right now. I'm getting rid of this whole code here and say instead, I want to have our image. One of the images we just added. So I'll say there's an image with a name Highlands, like that. I press Option Command P to resume my preview. Very, very, very important shortcut. Use that one a heck of a lot. And boom, there are the Highlands, beautiful as they are, right there in our little canvas preview. Now this introduces two new things at the same time. One is image. This is another type of user interface control, just like text had before. We can place these things on the screen. And SwiftUI calls these things, images and text, views. They are a view on the screen. And one screen in your UI might be one view, or could be hundreds of views with many smaller views inside it. It's down to you how you build up your UI. But one view in this case is just our image Highlands. And you can actually see that our content view is also a view. So image is a view, text is a view, the content view that Xcode made for us is also a view. That's why it can be drawn on the screen. And what this line of code here actually means is I want to create a new custom data structure called content view, and it's a view. I want to draw this on the screen as part of my UI. And it means whatever's inside there, which in our case is this image of Highlands, will be drawn to the screen, which right now is this sort of fixed image. Now, as you can see straight away when I refresh the screen, boom, there is a Highlands picture, and SwiftUI is smart enough to look inside our asset catalog where we place the image, load it out of there, the correct resolution, and draw it onto the screen. Very, very smart way of working. All we're going to do is provide the image name right in here, and it'll load the correct picture, boom, like that. As you can see, images are naturally drawn at their built-in size. That's their job. SwiftUI knows the size of this picture is that big exactly in pixels, and it'll draw it the correct size for the screen. If we want to, we can make this draw at a different size. We can say, apparently there's no Highlands in the folder. Is there not? Highlands? I see it. I have to check that folder perhaps. It's drawn its default size. If we want to, we can say, actually, make this stretchable. Make it customizable. Don't make it its default size. Make it resizable. This is done with modifiers, which are special lines of code you add after views that affect or modify the way the view works. So we'll just say image Highlands, and on the next line, dot resizable, like that. Make this thing be resizable. And you can see, wow, now it's completely stretched to almost fill the screen. Now, it is convention, which means it's not required, but we mostly do it anyway, to put modifiers on their own line after the thing they're modifying. And often you'll indent it one place like that, make it clear where views start and where their modifiers start and end. It's convention. You can totally have image resizable like that. It means exactly the same thing. But because you'll often add many, many modifiers, you'll add it on its own lines. You can have them stacked up so it's really clear where the files actually start and end, where the views start and end. So now that picture is resizable, you can see it's going to fill nearly all the screen. Not all the screen, nearly all the screen. If you look, there is some white space at the bottom here and at the top up here. And this is SwiftUI being real clever because it knows the bottom of this iPhone 12 screen is curved. It's a rounded corner on that screen. And the top, that's where the notch is, where the camera display area is, with the sort of sensing stuff and the all that kind of jazz at the top there, the clever stuff, right? The notch. And as a result, if it put the picture at the very bottom of the screen and the very top of the screen, it would miss off some of the picture. It would be invisible. And so, potentially, our user might miss some important information. That'd be bad, right? No one wants that. And so it brings the image down a little bit to make sure the entire picture is completely visible all the time, which is great. Now, of course, stretching our image like we've done here really isn't great. You know, looking at the Highlands, unless you know your Scottish landscape very, very well, you maybe could not tell that's stretched, like out of aspect ratio. But if that were a picture of a person, they'd look pretty skinny, right? They'd look really super thin, which isn't great. What we don't want to do is warp the image like this. We want to scale it up a little bit so it fills the screen, but keep the aspect ratio so it's not stretched so much. And again, SwiftUI has another modifier just for this. We can tell it to scale up our image to fit the available space available for the image while also keeping it in its correct shape. So another modifier, so another new line, will say .scaled to fit, like that. And now it's not stretched anymore. It goes edge to edge correctly, but it's not stretched anymore. It fits nicely on the screen. Now, at this point, normally folks start asking me, how did I know to do resizable? How did I know to do scale to fit? How did I learn these modifiers? And honestly, the answer is I spent a lot of time reading Apple's documentation, watching conference talks, reading books from other authors, and writing stacks and stacks and stacks of my own code. I literally just learned it the same way you're going to learn it, by watching other people, learning from other people, asking questions of other people until I understand it fully. Lots of experimentation. There's no fast track to learning this stuff. But you might have noticed when I pressed dot here, some code completion pops up. Did you mean anti-aliased? Did you mean rendering mode? Did you mean accent color? Did you mean da-da-da? And you can scroll through this to discover things. You can find new modifiers to try and experiment and just basically noodle around until you find something you like. You need to know, if it's your first time doing any serious coding, senior developers, even the most senior developers, will use code completion a heck of a lot. They rely on it very, very heavily. I use it all the time. And as a result, you should get comfortable with it. Get used to using it. Lean on it heavily. Don't be afraid to lean on it heavily. It's really, really important to get used to that. There's a question here from Nuno Pereira, who asks, what's the difference between scale to fit and aspect ratio? So there is a second modifier we could have used, which is aspect ratio. Aspect ratio here. If you look, it should say scale to fit. If you bring up the help window, I believe, unless I've changed this, the help will say, there we go, this method, scale to fit, is equivalent to using aspect ratio with a nil aspect ratio. So it's the same thing behind the scenes, it's a little shortcut. Kilo, that is super generous. Thank you so much, my friend. That's amazing of you. Folks, there is a charity link to use. Please use the charity link. I want to make sure the charity gets all the money directly. There's a charity link to use. If you want to give my dogs the treats, you can do, but the charity link's the one you want to use. Anyway, back to our code. Our image now fits a screen correctly without being warped, which is much, much nicer. Now, just having an image by itself isn't much. Now, anyone can draw a picture on the screen, right? What we want to do is say below it what this is a picture of. So we'll say below this, I want to have some text. And we'll say the text should be the Highlands. Yeah, brilliant. And look at that. Almost certainly not what you expected. Like, I wanted the text below the image, but not that far below the image. That's really far below the image, right? That's a different whole iPhone preview below the image. And this is actually intentional. This is normal and serious. This is exactly the right behavior from SwiftUI. It's doing the right thing. The problem is that SwiftUI doesn't understand what we mean. We have an image here and text below. We can see one is below the other. But SwiftUI doesn't understand how we mean to position them. Do we want them side by side, left and right? Or one above the other? Or stacked vertically above each other like this, so one overlaps the other? Something like that. It's all sorts of confusion, and so it renders it as two different views. I don't know what you mean, so here they are separately. And so, we've got to be specific. We've got to tell SwiftUI what we mean precisely. Computers love us being precise. In this case, we want to stack up our image and our text vertically, one above the other. That's what we want. And it is done using a different view type called VStack. A VStack, vertical stack. We're going to put it around our current code like this. VStack, then all our current code, then end the VStack. And now, that's exactly what you would expect to see. The image and the text, one above the other. Much better, right? That's what we wanted, right? So that gets us through the first step of our little project. And I'm going to show you lots and lots more. But first, I want to make sure this is actually sinking in at least a little bit by asking you a short quiz. Now, folks who are here live, I want to remind you, please do not, when you see the questions, do not just jump in with the answers straight away in the chat window. Give folks who are watching later on the chance to think about the question and answer it themselves before you answer. Even if you're being hilarious and post the wrong answer completely, just please don't. Hold up and let them have a chance to see the quiz fully. It's only 3 questions, nice and simple based on what we've learned so far. There's your code, that's what we've learned so far. Here is the short quiz. I'll just slide it across the window because I'm being a bit lazy. There we go. Quiz number 1. So for this thing, quiz number 1, we have a few simple questions that hopefully you'll see on the screen. Like that. Quiz number 1. Where do we store images for our app? Is it in the project navigator, in the asset catalog, in our Swift code, or on the App Store? Where do we store the images for our app? Have a little think. Pause the video if you want. Rewind it. Please don't answer in the chat. Please do not answer in the chat. You know who you are. To give folks watching later a chance to follow along and think for themselves. Hope you had a good think. The answer, of course, is in the asset catalog. Again, folks, please do not answer in the chat window until the answer is revealed. Otherwise, you're spoiling it for folks to come along later on to watch the video at a later point. Again, Patrick, even the wrong answer is not hilarious. Please just slow down. Give folks time to answer later on. Remember, putting it in the asset catalog allows Xcode to optimize the images for us to make them more efficient to load on iOS devices, smaller and faster to load. So it's a good idea to use asset catalogs for these things. Next up, what do JSON files hold? Is it audio? Is it images? Is it code? Or is it information? What do JSON files hold? Is it audio, images, code, or information? Again, JSON JavaScript object notation came from the JS world originally, but it's now used in Swift, in PHP, in Python, in JavaScript, C++. It's used basically everywhere at this point. Hopefully you're thinking, it is information. Some kind of data you want to have in your program being sent from one place to another place or loaded from your app bundle or whatever you want to. Lots of folks use JSON. It's very, very good. Question 3. Which modifier lets us stretch an image? Is it scaled to fit? Is it scaling to fit? Is it resizable? Or is it stretch? Which modifier lets us stretch an image? Remember, images are drawn at their natural size by default, the correct natural dimensions by default. Which one of these lets us stretch an image? Have a little think. Pause the video if you want to. And the answer is resizable. And you will forget this. You will forget this. It just happens, right? You'll be sitting there saying, I've tried to make my image change size. Why is it not changing size? Because you haven't added resizable. You can add scale to fit, you can add whatever you want to, and it won't change size unless resizable is on there. You've got to have that on there. Okay. Next up is quiz 2, which is coming a bit later on. So first things first, let's get back to Xcode. Okay, hopefully, apart from the few folks who were ignoring my very clear instructions not to answer in a chat window, apart from that, hopefully most of you followed along nicely with the little quiz. Don't worry if not. We'll be going over these things again. You've got enough time to repeat it here or rewind it if you want to. It's down to you. Pablo, that's very generous. This is a charity fundraiser on my birthday. I would love it if you could donate to the charity directly. They look after homeless folks. They look after folks leaving prison or folks escaping domestic abuse. It's a great charity. Go and check them out. Anyway, right now, the text below our image, the Highlands, is tiny. It's real small, right? And this is because we didn't tell SwiftUI how to render the text. And so it'll use the default system font, which is like 17 point SF, right? San Francisco Sans, like that. That's a default system font in iOS. So it's small. It's not very important. It's not really a title at all there. But we can change that. We can say, hey, I want you to have a larger font, please. Be more apparent and big on the screen. And we can do that with a different modifier called font. We can say this thing has a font using .large title. Give me a large title font for this. And boom, you'll see immediately it's much, much bigger. Now, if you're working in Pages or Numbers or somewhere else, you'll be familiar with the idea of saying, actually, I want to have Helvetica in size 36 point or whatever, right? We're used to having specific font names and specific font sizes. Here, I have not done that. I've said, give me a large title font, which means I've described what kind of text this is. It's a large title. I'm letting SwiftUI figure out what that means. What does that mean on this device? What size should it be? What font size, font name should it be? And so forth. In this case, we use large title. Give me a nice large font. And you might, if you look real closely, have noticed there's a little bit more spacing above the text as well. If you look super close, here's without. Boom. The text is there. Really micro-sized. If I zoom in a little bit, it's even better perhaps. There we go. There's the Highlands. And now if I add the modifier, the spacing will increase. Extra gap. SwiftUI is being super smart. It knows bigger text looks better with more breathing room around it. It'll allocate a bit more spacing above it while bringing up the font size. So the large title font is really helpful for getting great layouts easily. But it also means, and this is really important, it also means our UI will scale correctly across different kinds of devices as configuration changes. Because it's very common for users to say, you know, I need fonts that are bigger across the board. Make all my fonts bigger so I can read the screen more easily. Or other folks might say, actually, I want to have a really dense screen full of information. Make the fonts smaller. And as a result, they'll adjust what's called dynamic type, a system-wide setting that controls how big or how small fonts are. And large title respects that automatically. It knows to get bigger or smaller based on a user's settings. And we can try it out. If I run our current code, that's Command R again, run our current code. You can also press this play button up here if you really want to. So Command R will build and run my code again on the simulator. Here it is here. I'll put it over the chat window just temporarily, like that. And in Xcode, the very bottom of your code editor is this sort of like Nintendo Switch icon thing here called environment overrides. And when you press that, you can dynamically adjust the way your UI looks to simulate different kinds of settings. In this case, I enable text, and I can drag this thing up or down, and in theory, there we go, it's getting bigger and smaller. So that's if they have super large fonts or super small fonts. Large title understands how to adapt itself automatically to fit those different sizes. So it's really, really a good idea to let the system scale your fonts naturally. Use large title and similar kinds of font sizes to work with your layouts. Russell Gordon asks, what was that keyboard shortcut? There are two I've shown you so far. One is Command R to build and run your program. And one is Option Command P to resume your preview. Command R, build and run. Option Command P to resume the preview. They're both really, really important. Use those two a lot. Okay, anyway. At this point, as you can see, our text now is looking a lot nicer, a lot clearer on the screen, which we wanted. But we can make it even bigger. We can ask for this to be more clear on the screen. Because this is the main title for the screen. So I'm going to say below large title, another modifier. I'll say dot bold. Make this text large title and also bold. I press Option Command P to resume my preview. It automatically disables when you press Command R to run your code. And boom, we now have a nice large title font in bold. Now, I'm going to add one more modifier here because some of our place names have quite long titles. And when they go over multiple lines, I want to control how that looks. Folks, you will just get banned from the channel immediately. I've got zero tolerance for morons coming in and saying those kind of horrible things. Anyway, the Highlands fits fine here, but if we had longer problems, a longer text story, it won't look so good. For example, if we had something like the amazing Scottish Highlands, now it's crossed two lines. As you can see, SwiftUI is left aligning it across two lines, which is very clever. It figured out multiple lines automatically and displayed it nicely, hooray. But it went left aligned, which doesn't look great for titles. It's great for body text, but not for title text. So we'll add one more modifier here to control the way SwiftUI aligns its text when there are multiple lines. It's got a very precise, wordy name. The modifier is multi-line text alignment. I'm going to ask for dot center. Center align this text when it goes across multiple lines like that. You can add as many modifiers as you want to a view. Really, you can add 10, 20, 30, whatever you want to. And you can even add them multiple times a lot of the time to really increase an effect. For example, if you had a shadow, you can add multiple shadows to get different kinds of glow effects and similar. So now I've said, if we happen to go across multiple lines, make sure we align it nicely. So it's a nice title style of font. And that works. I'll put this back to just the Highlands again, what we had before. Okay, we have our image. We have our title, this place name. Below that, I want to put a location as country to say where this country is. So I'll say this is text United Kingdom. And I'll give this thing a font of dot title. And that is smaller than large title, as you might be able to guess from the name. As you can see, it's not bold anymore. There's no bold modifier, but it's a bit smaller as well. And that makes it clear there's a reading hierarchy. The Highlands is the most important thing, and the UK slightly less important. And we can really drive that home by giving the UK, the country name, a less prominent color as well. We could say this has a foreground color of secondary. A secondary foreground color. When that runs it through, you'll see here, it becomes gray text. Now, just like setting font size, we've avoided saying exactly what color we're using. I haven't said gray or red or blue or tartan, this being Scotland. I've instead said it's a secondary. it's less important than some primary text. We didn't have one of these colors for our place name. The Highlands didn't have one. That's because text has a primary color by default. And a secondary color, this one here, is actually the same color as the primary color. That's actually the same color. That black and the gray is the same color. What's happening is SwiftUI adds a little bit of transparency to it. And so the white behind shows through, which makes it look like it's gray. And this matters because if we had a blue background or a red background, you wouldn't see pure gray, you'd see slightly bluey gray or slightly red gray, for example. So it'll adapt to whatever background's behind it automatically. And just like using large title or title for our font size, using secondary color rather than gray specifically is really, really important because it allows the system to adapt to different kinds of environment. And in fact, if we run the app again, I'll press Command R to build and run our current code we have here. And let's see how it looks. I'll put it just here. There we go. I haven't said gray or black. I've said primary and secondary. If we go back in Xcode to the environment overrides again, you'll see we can override the appearance, which allows us to go into dark mode or light mode. So here's light mode, and being well, go on, you can do it. Dark mode, boom, and bang. That black text is now white text. And the gray text is still gray, but it's now white text with black showing through with transparency. Folks asking for more advanced topics have missed the point of this stream. This is for complete beginners. If you have more questions about MVVM and advanced stuff, you're in the wrong stream. I apologize. Anyway, we haven't said gray or black or white or red or tartan, whatever. We just said primary for the default one is the default, but secondary for the other text. Adapt automatically to the correct colors for this layout. It's a much better way of working than saying white or black or whatever. It's under the webcam. Sorry, folks. Let's do that again, shall we? I can make my webcam smaller, perhaps. Let's try it again. There we go. So it's flipping it around. Okay. Hopefully you can see that now. Well, you can see it now, remote. There you go. Okay. So, secondary works really nicely. Next up, we're going to add some text about our destination below this thing so we can see more about our destination. And to do that, I'll start by making an empty text view. So text and then double quote, then end the text like that. So there's nothing in there just yet. Empty text view. And I'm going to go into locations.json and steal all the description text, all this stuff here, from this quote to this quote, like this. And then Command C onto my clipboard, then go back to content view and paste it into the text, like that. So I'm pasting stuff from our JSON file directly into our Swift code. And you might notice, if you look carefully down here, there's some text where it's like \quote, the place of the Gales, \quote. And the reason for that is because these quote marks, double quote marks, mark the start and end of our strings in Swift. And this text itself contains quote marks. And so, as a result, if we didn't have this \, Swift would think, aha, the string ends there. Look, the color's changed to be white. It's confused, like, how does the string end in the middle of the thing? It shouldn't end there. The \ means, no, it doesn't really end there. This is actually a quote mark inside my text. It's called an escape character, and they're used quite a lot to do things like line breaks or quotes inside text and so forth. And this allows us to have all that text from our JSON right there inside our Swift code. After that, we're going to paste some more text from JSON to give the user a little bit of extra information about this place they're going to. Little sort of cool fact about the place they're going to visit. And what I want to do first is have a little marker saying, did you know? And then the other text. So let's do that now. below this big, long, pasted text, I'm going to say another text. Did you know? Then the font, I'm going to use title 3. So a slightly smaller title. And put that into bold. So that now says, did you know, below our previous text. And as you can see in our little preview here, it's placed directly below the first piece of text. And that's a bit weird. You know, when we're reading articles or whatever, the heading for something usually has some spacing before it. So it doesn't directly touch the thing before it. Otherwise, you're thinking, is that a footer or a header? I can't quite tell what it is. So what we want to do really is say, actually, before this text, just add some space and a little bit of padding to this thing to pull it down so it isn't too close to the previous thing on our screen. And in SwiftUI, this is solved using a new modifier, which is often the solution in SwiftUI, called padding. Add some spacing before this thing so it fits in nicely. And if we use padding all by itself, like this, it means add spacing on all edges. You can just about see it here, this purpley line around my box. That's the padding I added around it. But you can also say, actually, I only want padding on certain sides. In our case, the top. So I'll say padding dot top. So as you can see now, the purple box, the preview of where my thing is sized on the screen, fits tightly around the text, apart from the top, where there is some spacing. So that's our Did You Know title. And now we can paste our extra information text. So we'll do another empty text view like that. And we'll go ahead and paste into there some more code, or more text, sorry, from our JSON file. So in locations.json, this whole more thing here, this is extra facts about the Highlands. I'll copy everything inside the quotes to my clipboard and then paste that into this text view like that. So I've made lots of space for all our text. Now, when you do that, you're going to see our screen's really full. I mean, this is a 12 Pro Max. This is the biggest iPhone that exists in the world at this time. Who knows what will launch next year, but this is as big as it gets right now. And, question here from Swift Fanatic. Good question. Is there a default value for the padding you provide? Yes, the default is called adaptive padding, which means use whatever padding SwiftUI deems sensible for the current layout on the current device. So on large devices, it'll use more padding. On smaller ones, it'll use less padding. But it'll do an appropriate amount of padding for this size of text in this device. That's the default. If you want to, you can say, actually, I want to have a specific amount of padding. I want to have exactly 50 points of padding, for example. And that'll push it down quite a lot. But in our case, I'm using adaptive padding. Push it down by some amount, just enough to work. Anyway. At this point, our 12 Pro Max is completely full. There is no space left on our 12 Pro Max, which means our text doesn't even fit properly at this point. If you look carefully, you'll see it says literally me ... or in 2012, th ... We are out of space. This screen is full, even though it's super big. And this is because the text is too long. There is simply no way we can squeeze all that text and the title and text above and the picture onto that screen. It is not possible. What we've got to do is tell iOS, actually, don't try and squeeze it all in. Let the user scroll. Let them go up and down to, see more if they want to see more. And this is really, really easy in SwiftUI because we have this VStack to do a vertical stack of stuff. We're going to change that to be a scroll view. Just change VStack to be scroll view. That one tiny change. And now it all flows correctly. I can press Command R to build and run our code. And all being well, we should see our picture. There we go. I can now scroll around and see the full text for the picture like that. It's much, much better. With one tiny change, just change your VStack to scroll view, bang, it looks much, much better. Now this screen is almost done. Right? There's not much more to this screen, but I want to add at least one more thing before we go on to the next step, which is handling the top part of our screen. So if I scroll around, you'll see I can scroll up here. If I go even further, look at the top of my screen. You see the clock area here, the top right, left corner of my iPhone, plus the Wi-Fi and the battery area. It goes directly over my text and becomes hard, if not impossible, to read, which is not very nice. We don't want to have that kind of thing. We want much, much clearer code for our layouts. And there are multiple ways you could fix this. If you're making a game, for example, it's common to hide the status bar entirely. But for apps, that's not really a good idea. Not many apps do that because users want to know what the Wi-Fi signal is like or what time it is and so forth. They want to have that status bar around. Question here from Rainy David. Could I explain what VStack is? Great question, Rainy. So a VStack is a vertical stack of views. So if you have a VStack, then text, 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 it'll place them vertically. There are other kinds of stacks. You could say H stack for horizontal stack. So if you had text, 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 it'd be laid out horizontally. Text, text, text. Left to right, or for you, this way, presumably. This way, right? It's all flipped with my camera. It's flipped left to right, like that. A VStack arranges things vertically. There's also a Z or a Z stack for depth or depth, to have things one on top of the other if you wanted to. So those are the stacks we have to work with. A scroll view will automatically place things into a VStack for us, which is what you're seeing right now. So this is our screen so far, but I want to look at a way of fixing our top bar here. So we can see the text and the status bar clearly, because most apps will not want to hide the status bar. An easy fix is to use a navigation view. And navigation views exist in lots of places in iOS. You'll see them in settings, for example. This bar at the top, this is a navigation bar. And you'll see as I scroll around, nothing overlaps or underlaps the clock anymore because that bar sits at the top automatically. It's automatically solving the problem for us, which is amazing. We want one of those. And you'll find that in the Mail app, you'll find it in the News app, you'll find it in Reminders, you'll find it in Notes, you'll find it so many places. It's very, very common to have these kinds of navigation bars up there to fix these problems. They have other benefits, but it's a major, major one for sure. And in SwiftUI, we get one of these things with a new view type called Navigation View. A navigation view, and it comes with a navigation bar free of charge, which is great. And we're going to place this thing inside trekkerapp.swift, which will be in here in our application added for us. We haven't been in here yet. As you can see, this thing just shows a content view. This decides what's the first thing to show in our application. The answer is a content view. We can customize that. We can say, yeah, I want a content view. Of course I do. It's great. But I want to wrap this thing in a navigation view, like that. So just put navigation view around your content view. And with that one simple small change, we can go ahead and press Command R to build and run our code again. And you'll see now there's big white space at the top. As I scroll around, we get, you can just about see it maybe on my screen, this kind of frosted glass effect of text and whatever going beneath it, because we now can no longer overlap the clock or underlap the clock with our content. It's much, much clearer at the top, which is what you want. You don't want to have text overlapping the status bar. It isn't very nice at all. And in fact, with that in place, we can actually now customize that because there's all sorts of ways we can add to that to make it do more interesting things. The most popular one is to add a title to the navigation bar to say what screen you're on. So as they're scrolling around, it's clear where they are in the application, what they're looking at right now. And we can do that inside Content View. We can say, this content view, when this thing is being shown anywhere in an application, it has a navigation title of Discover. So I'll go to our scroll view here. I go to the very end of it. That's this closing brace here. Boom. Then add a modifier. Dot navigation title Discover. Discover. When I press Command R now, you'll see that title gets put up into the navigation view automatically. There it is. Discover. When I move it around, it fades away and goes small, just like settings did. We get this beautiful built-in iOS system behavior out of the box for free. Absolutely brilliant. Really, really nice. Now, someone asked, where is it? I think Dennis asked, here we go. Does this prevent the preview from showing your navigation view now as well? Our preview is actually controlled by a special bit of code at the bottom of our Swift file. This bit here, lines 39 to 43 for me, does not go into our finished application. Does not go to the App Store ever. This bit's just for Xcode to understand how to preview the current screen. And not enough folks realize you can customize this. Just for previewing, you can do what you like with this. You could say, actually, for previewing purposes, I want a navigation view around this. Show me how it would look in a nav view. And now when you preview again, you will see your nav view in the preview. And it does not affect even slightly the way the code actually works when it runs back in a simulator or on the App Store. It's just for previewing in Xcode's canvas. So you can customize that all you want to. It's down to you to futz around with. Now this screen's basically done, right? We're done here. This looks pretty good. I don't particularly like the way the text goes edge to edge. I think it looks a bit tight here and down here as well. And we can solve that with more padding. You know padding already. We can go ahead and say padding for this long piece of text will be what? Now we could just do padding by itself, which means add padding to all 4 sides of the thing, but that'll push it away from the country above it, which doesn't look great. What we want to do is say add padding only horizontally to the leading and trailing, the left and right edges, not top, not bottom, just the left and right edges. We add the same modifier to our second long text view down here. Boom. Add padding in both places. And now I press Command R. This should look pretty good. What do you think, dog? Go on then, you may have a treat. Go on, have a look at the code. What do you think? Does it pass? Yeah. This one's Aria, by the way, if you like dogs. They are Samoyeds, both of them. Anyway, so you can see we now have padding on both text views. It's looking really, really nice. There's no more underlapping going on. This looks good. At this point, this screen, I think, is basically done. I'm happy with this view as it is. And so I want to pause just temporarily and switch across to a quiz to make sure you're paying attention. Give you a chance to review what we've covered already so you can understand and review. And if you need to, rewind and try again. Please, if you are live watching this, do not answer in the chat window with the right answer, with the wrong answer, with any answer. Do not answer in the chat window, please. I can't be any clearer. Give folks who are watching later on the chance to guess themselves, to think themselves, to have a go. Otherwise, they'll find it harder to learn. Okay, I've been really clear again, I feel. We'll see who ignores me once again. Let's go ahead and press play. So here's quiz number 2. Which of these font sizes is the largest? Title, big title, primary, or title 3? Which of these built-in font sizes is the largest in SwiftUI? Title, big title, primary, or title 3? If you're watching later on, go ahead and pause the video, have a think, and then answer. I'm in no rush. I'll wait. These folks here can wait, I'm sure. The answer is title. That's the largest one there. Big title I made up. It's actually large title. That would be even bigger, but big title is actually wrong. Primary does not exist. And title 3 is smaller. Next up, which modifier adds spacing around a view? Is it padding? Is it spacing? Is it margin? Or is it resizable? Which modifier adds spacing around a view? Is it padding, spacing, margin, or resizable? Have a go now. Hopefully you figured it out. The answer is padding. Now, this operates cunningly different to the way you'd expect it to work if you come from the web world, where you have padding and margin and they do different things. you need to only have padding, I'm afraid, in SwiftUI. There is no margin spacing I made up as well. And resizable is to make images stretch out on the screen. So the answer is padding. And question 3, which view makes a navigation bar at the top? Is it VStack? Is it navigation title, navigation bar, or navigation view? Which view makes a navigation bar at the top of the iOS screen? Is it VStack, navigation title, navigation bar, or navigation view? Have a think now. Pause the video if you want. It's down to you. Give my dog some treats in the meantime. Come on, doggos, where are you? Nope, they're clearly not hungry anymore. They've gone off somewhere. The answer is, of course, navigation view. And we'll have quiz 3 shortly, but not just yet. Let's head back to Xcode first. Back to Xcode. Okay, so far we've been focusing entirely on our layout, and I hope you can see our current way of working is pretty inefficient. We're just copying and pasting code from a JSON file into vast amounts of Swift to handle one place we can visit here, which is not great at all. We already have our data right here in locations.json. How do we get this onto the screen for all the other places we want to go and see, like the Black River Gorges or Verona in Italy, a beautiful, beautiful city? How do we get that in our code without copying and pasting absolutely everything? What we really want to do is write some code that's able to find locations.json in our app bundle, in that big bundle of pictures and JSON and code and so forth. Find that file and load it out of there into our program so we can reference it from our code to actually use that dynamically when our program runs. So rather than try to type out every possible location imaginable, we instead read it back from our code like this. And we can do this. It's what Swift's for, right? So it's good at this kind of thing. To get started, press Command N, make a new Swift file. Alternatively, you can go to File, then New, then File. Command N's easier. And choose Swift file. And this lets us create a new Swift file, a new separate piece of code. Still in our project, still in the same application, just now different. And I'll call this thing location.swift. This is going to describe one location from our data, from our JSON in here. So we can reference that in our code. So rather than sort of copying and pasting all our code again, we load it once into these objects and read it from there. So I'll make this file location.swift and press create. Boom, there it is. And this thing is going to hold all the data from our JSON file. Now again, you added this thing earlier, this location JSON file, this thing right here. This is all our data we want to add. You can see there's stacks and stacks of things in here. Oh, here you are, dog. You were a bit slow, weren't you? This is Luna, by the way. Come on, Luna. Come on. Come on, work for it. Good girl.
Also me.
Also my daughter. Hello. Here, give the dog a treat.
Luna, come on.
Okay. So what we want to do is create a custom data type in here that will hold everything for one of our locations. Every piece of data in our JSON file will be in one custom data structure in Swift. Load it all in here. And this means Swift is going to allocate enough memory, enough RAM on the device to hold the place name, the coordinates, the description text, yada, 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 all that there here for us to handle. And so we're going to make a new data type, a new structure to store our data. And we do that by saying struct, a new custom struct. And I'll call this thing location. It holds a single place. It'll hold Verona. It'll hold the Highlands or wherever you want to have one place. And now what we want to do is make enough values in here to store everything from our data. All this JSON file here has to be mapped into this data. So you can see there's an ID, a name, a country, description, more, latitude, longitude, here a picture, more pictures, advisory, We can load those things into our code. We'll do only a handful here, just enough to get started. And it looks like this. I'll give you all the code first and then walk you through what it actually does. We'll say this thing has an ID int. And that ID matches ID from our JSON. It has a name string. And again, name. The same names from our JSON file. We have a country string. UK or US or France or who knows what we've got. We have a description string. We have a more string with extra little hints and tips about the place. We have a latitude double. We have a longitude double. We have a hero picture string, and we have advisory text as a string. That's enough for now. That's a lot of code. I know it's a lot of code. I'm going to walk you through it step by step. First thing, this creates a new custom data structure called location. And everything inside this tells Swift what kind of data a single location has. And these things here from me, line 11 to line 19, are called properties. There are properties of location. Every location has an ID, has a name, has a country, has a again and again and again. Like that. And you can see we have lots of them. And they all have exactly the same name as in our JSON. That's intentional. You give them exactly the same name as your JSON names. After each property, you'll see a colon, then some more text, string, or double, or int. And this tells Swift what kind of data this is. What is name? What is advisory? What is longitude? What is ID? And so forth. There's quite a few lines of code here, but we're actually only using 3 types of data. This first one, ID, is short as an integer, int. Int's short for integer, which means a whole number. Integer comes from Latin, meaning whole number, integral. And it means that when Swift reads the ID value from the JSON, it'll expect to find a whole number there. 3.141, not a whole number, will cause a problem. Next we have string. This is text. When we had text in our content view, inside double quotes like this is a string. This is a string. More strings, here. These are all strings. All strings in Swift have double quotes, like that. And finally we have double, which is a number with values after the decimal point, like 3.141. Now, double is short for double precision floating point number, which is a fancy way of saying this can hold tiny values such as 0.0000001, or very large values such as 444,444,444.444. Right? It holds lots of data in a big number with a decimal point and something after there as well. Now you will notice, if you look carefully at my code, our property names all start with a lowercase letter, whereas our type names, string, double, int, location, content view, and similar, start with a capital letter. This is another convention, right? Just like the way you place modifiers in their own line, you can ignore this convention if you want to. You could have had latitude with a capital L if you desperately wanted to. But a convention means we all follow these informal rules to make our code easier to understand. If it starts with a capital letter, it means it's a type of some sort. Int, string, location, content view, whatever. Starts with a lowercase letter, it means it's not. It's a local value you can work with. Swift does not care, right? You can name yourself however you want to. It's down to you, as long as you are consistent. It's all that matters. Now, we aren't giving any of these properties ID, name, country, values. We're not saying your name is the Highlands, for example. All we're saying is name will be some kind of string, we don't know what. And this is because we're telling Swift what it will hold, so it can then load that from our JSON and actually use it. Now, when creating data like this, I prefer to create alongside it some kind of example data that we can use in previews in our little SwiftUI canvas. You can see your preview working with example data just to make sure it works correctly. Don't load the real stuff, here's just some sample data. And so we can do that in our code down here with an extra property to location. We can say, let example be a location. And all we're going to do is fill in example values to show in our data. So I'll say our example ID, 1. Our name is the Great Smoky Mountains. By the way, you can press tab to move between these little code completion placeholders if you want to. So Great Smoky Mountains is the name. The country is, of course, the United States. Description will be a great place to visit. The more text will be just more text here, just example text. Latitude will be 35.6532 and longitude minus 83.5070. That's actually accurate, I believe. The hero picture will be Smokies. And the advisory text will be beware of the bears. That's our example. So we have a way to preview a location without having to read our JSON code. Just a quick example. But when I've done that, Xcode's going to complain. If I press here, it'll say what the problem is. As you can see, value type location cannot have a stored property that recursively contains it. What it means is that by adding an example location directly to the location struct, we have accidentally made something infinitely big. Literally infinitely, will never end, big. Think about it, right? Every time you make a location, you made a new location, it will include an example location as one of its properties. But the example location itself has the property example. So it'll make its own example, which will make its own example, own example, own example. Right? It's like staring into the mirrors adjacent to each other, right? Like this, opposite each other, sorry. You'll see infinite example locations being made, hence the infinite recursion happening here. This is why Xcode's unhappy. This is great. I think this is fantastic. Xcode will not even build our code. No, you cannot run your code until you fix the problems. That's one of the power features of languages like Swift as opposed to JavaScript. It will check your code before it runs it. We know this code is not valid. And so what we want to do is fix this impossibility. We want to say, don't worry, it's going to work out well. If we add one word before this let, like static in this case, it'll solve the problem. And what it means is this property, example, exists only once and is shared between all locations. So all location structs share the same example property rather than creating a new one for every location. And in this case, it means it's created once and shared everywhere rather than infinitely many times. This is good. Brandon asks, what is the difference between SwiftUI and UIKit? UIKit is significantly older. 10, 11 years, 12 years, probably 13, 14, even more, even years older. Obviously, Apple using it internally before it hit us. Whereas SwiftUI is brand new. It shipped last year, 2019. It is very, very new and optimized for Swift. So it's significantly easier to learn and faster to build with. So by adding static here, we're saying don't make infinite numbers of example locations, make one and just share it everywhere. And so Xcode's happy again, which is great. And now we've defined our data. This is our location right here. We can go back to content.view.swift, up here, that layout we made earlier, and make it use one of our location structs. So rather than having to type everything by hand, say, hey, use a location, please, that has a name, that has a description, has a more, has a country, has, always things like that. And if you remember, content view is itself a struct. It's a data structure all by itself. That's a struct keyword right there. And that means it can have properties of its own, just like location had. Now, we absolutely could say in here a whole bunch of properties. We could say, let image name is a string. Let location name is a string. Let country be a string. Let main text be a string. Yeah, you get the point, right? This is super tedious. And so this is clearly not nice. There's lots of duplication happening here, a lot of typing. We're having to move around lots of text. Instead, a better thing to do is to say, if you want to have one of these views, if you want to show a content view, awesome, love it, go for it. But you've got to pass in a whole location object already configured, already ID, location, country, main text, already done for us. Instead, we just say, let location be a location. You must give me a location for this view in order to use it. And with that change, once again, you're going to find Xcode complaining. It's unhappy. You see, there are two places in our code that use content view. One is down here. There's content view here. And neither of those specify what location to show. We've just said, hey, if you want to make a content view, great, go for it. But you've got to give me a location to show. And we aren't doing that here. We're saying, yep, show a content view, but not saying what. And so Xcode's saying, you're missing an argument for parameter location. You've got to tell me a location to show here. What do you want to show? And this is where our example value comes in really, really useful. We can say, okay, show content view, and for its location, show location.example. That example we made earlier. And that will solve that problem. But our code still won't build, because in Trekker app.swift, we also make a content view with no location being passed in. So we've got to fix it here as well. We'll say, fine, yes, create content view with location.example. Like that. And this is better, right? We can go ahead and pile our code now. It should work correctly now, which is great. But back in content view, if I press resume here to resume my preview, it'll have a little think. Come on. Okay, there's my preview. That's it running right now. And it's still showing the Highlands. It's not showing Smoky Mountains. All that text in our example location is not actually being used. And this is because, yes, we've said you've got to pass in a location. You've got to make this thing with a location. And we have sent the location in right here. And again, in our app. But what we haven't done is take out all that hand-typed stuff. It all uses the hand-typed stuff, not the dynamic stuff being passed in our code. And so what we want to do is use this property. This is a location. It has a name, has a country, has other stuff. We want to use those values inside our layout. So rather than saying image Highlands, I want to say use location.picture. Show me the correct picture for the location we asked for. Oh, sorry, here a picture. There we go. Show me the correct picture for the location we passed in. And bang, now we have the Smoky Mountains. The text below it shouldn't be just the Highlands every time. It should be location.name. And hopefully, there we are, Great Smoky Mountains. And then ditch UK and say location.country. And for this text area here, let's take all that out. Bang, much better. And say location.description. And for the second text area, down here, we're going to say location.more. So the more text below. And now it is loading the correct text being passed into the view from this preview or from the main application launch somewhere else. So it's showing dynamic text. And that is a little better, right? We can now see the example data from our location struct being used rather than typing it all by hand into the thing. But clearly, this isn't actually that much better. I mean, it's dynamic, but only just. It's still going to pass in the example stuff again. Goodbye, Ahmed. You're getting blocked straight away. Shame. Did they know it takes one click to block folks on YouTube? I've got no idea. Anyway, it's clearly not good. We don't want that. What we want to do really is actually show a real location from our JSON data. Load the actual JSON and show it. And this takes a bit of work to do. Now, what we're going to do is we're going to make another new data structure called locations, S, plural, to handle multiple locations. And this will be responsible for loading all the locations for our app and then storing them somewhere safe. So they can be used throughout the whole application to see multiple locations in our software. So first, we'll make another new Swift file. Go to the File menu, choose New, and choose File, or press Command-N, whatever works for you. New file. Choose a Swift file, and press Next, and call this thing Locations with an S on the end. This is going to store multiple location structs in one place. So Locations, and press Create. Now this time, we're making a new custom data structure, but we'll define it differently. We'll define it like this. Class locations, observable object, like that. So now we've said class rather than struct. And we also have this bonus observable object bit at the end. Now Swift has two ways of creating custom data structures. You already saw one. We used it in location here and in content view. Cunningly, confusingly, it's called struct. So struct is a structure. That's one way of making custom data structures. And these are great. These are really, really great for any kind of data you don't want to share. That's their job. Because every time you use it in a different part of your program, Swift makes a unique copy of that data. So you can't like change it in one place and change it everywhere. That'd be a disaster. You don't want that. And so what we can do is we can say, oh, my YouTube comment was kind of frozen. Cool. Thanks, YouTube. Oh, yeah, figured out now. Good job. Well done. Okay, there we go. It'll make unique copies of the structs, which is great for keeping our program easy to understand. However, classes, like here, are different. They are designed to be shared. And we're using one here because we want this locations object, this class, to load locations.json from our app bundle once, and then share it everywhere in our program. We haven't got to load the JSON file again whenever we make a new copy of this thing. That'd be horrible. It'd be really, really slow and wasteful. We want to load the JSON only once. It's faster and uses less memory. This observable object thing, this is very similar to content view. We said there's a structure called content view, and it is a SwiftUI view. This thing can be drawn to the screen. Content view is a SwiftUI view. It's exactly the same here. Locations is an observable object. This is another SwiftUI thing. It means SwiftUI will watch this for changes. And if its object changes, SwiftUI will automatically update its user interface. Now, in this instance, it's not going to change, right? We're going to load the JSON once, show the countries, and that's it. We're never going to change it. But SwiftUI still wants to be able to watch it for changes that might happen. It's clearly not very trusting, but it's not going to change. Anyway, inside this class, we're going to add one property to here. Let places be bracket location end bracket, like that. Now, if we had written let places location like that, it would mean this class holds exactly one location, which is kind of pointless. But with the brackets, we're saying this is a new data type called an array. This thing will hold many locations in one place. There's one property, places, will hold all locations from our JSON file all at the same time. And it means it's capable of holding 0 items, 5 items, 100 items, 1,000 items. We don't know. However many we need to have. And we can then read them back out. We can say, hey, give me the first item. Give me the 10th item. Whatever you want to, as much as you want to. So arrays are really, really useful. Now, Xcode is back complaining at us again. This class locations has no initializers. It doesn't understand. And this is because there's a curious quirk of Swift here, where when you make a struct like location, Swift will figure out how to make the struct based on all the properties inside the struct. This is why we could make one down here in our example property. What we're going to do is provide a value for every one of the properties, ID, name, country, description, yada, 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 and it will work. Swift cannot do that for classes because classes are a much more advanced thing, a lot more power behind them. And so Swift will not make code for us to make a class. We've got to do it by hand. And this is called an initializer. And it looks a bit strange at first because they are special code that gets run when an object is made. When we make a new locations object, it'll run the initializer to configure it with basic settings. And it's our job, it's our only job, to make sure we give a value to every one of the properties inside our class. If we don't do that, our code simply won't build. So, first we'll add the start and end of the initializer, which in Swift is init, parens, open and close brace. That's an empty initializer. And you can see again, Xcode's complaining, you've got an initializer here, great, but you haven't initialized the properties. Places has no value still. And everything inside this belongs to the initializer. And it's our job to find locations.json inside our app bundle, to load it from there, and assign it to be this places array of locations before init finishes. Otherwise, it won't build. Now, this is a beginner tutorial for absolute beginners. As a result, I'm going to take some shortcuts here, take our code slightly faster, and this is one of those shortcuts. There are nicer ways to do what I'm about to show you, but it takes more learning, and it would slow the whole thing down with more complexity. So we're going to write some code that could, in theory, crash. And that means our app would, bang, just stop running, back in the home screen, confused where our app went to, right? And that's very rarely a good thing. I mean, sometimes, yeah, it's a good thing, but mostly it's not a good thing, having your app crash. However, in this instance, I'm really, really not worried about it, because this code must always work. Like, it cannot crash. I mean, literally must always work. If we can't load locations.json from our app bundle, it's broken. The app can't run. Nothing about our app's going to work, right? The best thing it can do is stop running immediately. This application is corrupt. And so I have no problem writing slightly crashy code here because it will never crash in production. It's quite safe. However, as you progress, 2 months, 3 months, 4 months time, you'll learn better, nicer, more flexible ways of doing this that I'm not going to cover here. Anyway, we're going to write this code line by line because it's quite intense, actually. It's the hardest code in the entire project. First, we've got to find the location of locations.json in our app bundle. Now, this thing, when it's installed on the phone, could be anywhere on the phone. Anywhere. We don't get access to the phone. That would, be insecure. We had to say, please, iOS, tell me where this file is in the whole iOS file system. And we do that with this line of code here. Let URL equals bundle.main.url for resource, and I'll use locations with extension JSON. Find me locations.json. So this thing here creates a constant value called URL. That's what let means. Make a constant, a value that cannot change. You can't modify it by accident. It's a good idea to have constants as much as you can. And it'll point to the location of locations.json, wherever that will be in our app bundle. And it's going to be a mile long. The URL will be really, very, very long because it's super hard to guess. It's all carefully sandboxed, we call it in iOS land here. So let's go try and find it. Now, of course, Swift doesn't know if that's going to work or not. We could have typed in here, find me shazbat.json, which does not exist. But we know it's going to work. We know this will definitely work until at the end of this line, we're going to put an exclamation mark. And this is where the crashiness comes in. Exclamation mark here means this will definitely work, I promise. And if it doesn't work, crash the whole application. Just crash entirely. And that's fine. You know, if you forget to include locations.json in your app, none of your app is going to work. So, you know, it's nothing you can do about it, right? So this has got to work. It will find it, otherwise your whole app is basically pointless. So we'll definitely find locations.json in our app bundle. Warning, when you work with file names, iOS is case sensitive, which means locations, lowercase l, locations, capital L, or whatever, are different file names. Make sure it's exactly lowercase locations, lowercase JSON, matching the file names you added to the project. Next up, we have the URL where our file is on the iOS file system. We'll now load it. We'll say let data equals try exclamation mark data content of that URL. And again, immediately you can see exclamation mark. This is another operation that can go wildly wrong. We're asking Swift to try loading this URL, whatever's there, into a new type of data called, cunningly, data. And that can hold whatever you want. That can hold text, images, audio, zip files, executable files, whatever you want to. They're all storable by data. Try and load this file into a data object for us to work with. And, you know, what happens if that URL doesn't exist? If it's like shazbat.json or something like that, right? If there's nothing at that URL, what then? Well, we've used exclamation mark. It will just crash. It'll just completely hard crash your whole program back to the home screen, just die immediately. Again, I'm fine with this here because if we cannot read the file, our whole app is corrupt and should not be running. You know, crashing sometimes is a good idea. If your app is in an unsafe state, then proceeding might destroy user data, like overwrite the save state with bad data. If you know things are corrupt and wrong, an completely invalid state, just bail out, do a hard crash. So I am fine using try exclamation mark here. Try and load that, whatever is in that file, into data here. And when this finishes, we now have all the data from our JSON file ready to work with, ready to read. Pure JSON. What should we do with it? Now, the final line here, the important line is, we want Swift to convert all that data into an array of location objects. That means thanks, Siri. That means adding a third line right now. We'll say our places property we added earlier is equal to try exclamation mark JSON decoder parens dot decode array of location dot self from data. And there's lots of code in there. Okay, I know that, you know that, it's pretty grim in here. It's not happy at all. Now, once again, we have an exclamation mark, right? This will force Swift. This data is definitely 100%, I'm willing to crash if I'm wrong, an array of locations. If it isn't, bang, dead. JSON decoder is a new type, like int, or string, or locations, or location, or content view. A new type called JSON decoder. Come on, you. Come on. Good dog. Yeah. a new type specifically designed to convert JSON to Swift types, like this. And we're saying, make a new one. Oh, hello, Luna. You too. Come on. Go. Hey, you just had one. Clear off. Little cheater. Anyway, create a JSON decoder and decode into an array of location. This is what's called a function call. We're triggering some special action, decode, that belongs to the JSON decoder type. And we're asking it to decode array of location.self, which means convert our JSON into an array of location objects. This self part here is required. And occasionally when folks are learning, they'll put it in the wrong place. They'll say something like array of location.self like that, with the .self being inside the brackets. Do not do that. It should be outside the brackets like that. The self part means, in this case, we're referring to arrays of location generally. Not a particular one, not this array of locations right here, but just array of locations just generally. That's what it means. And we send in the data we want to read from, which is the data we got from the URL. And finally, that goes into our places property. Now, hopefully, you're starting to see if this URL does not exist in the bundle, it'll crash. If we can't read it, it'll crash. If we can't decode it, it'll crash. You can see why many folks call the exclamation mark the crash operator. You've got to be really, really sure this is going to work. Not like 99% sure, 100% this will never ever crash to use the crash operator. Like I said, as you progress through Swift, become more familiar with it, you'll find better ways to do this. Much more elegant, descriptive, safer ways of doing this. But for now, that's enough hard code. I know it's a lot of code. That's like 3 lines, but it's pretty dense lines of code for a beginner. It is the hardest part of our entire project. That's it. Everything else is much, much easier than that. However, if you press Command B, you'll see our code does not work. Xcode's back to its complaining days. It's very angry. It's saying location must conform to decodable. What it means is, what it's trying to tell us really, is that Swift doesn't understand how to make a location object from JSON. It doesn't know how to do that. Now, if you remember, Rodney Farkash, thank you so much. As a reminder, folks, this is a charity stream raising money for a wonderful charity in my local town called Julian House, who look after folks who are experiencing homelessness or escaping domestic abuse or have learning difficulties or whatever. Please use the charity link posted by Prathamesh. It's in the description for the video as well. Send your money there to the charity. They need it more than I do. That's why I'm doing this on my birthday, just for this charity. Anyway, previously, we've seen our content view here is a view. There it is. And our locations class, this is an observable object. What we want to do is tell Swift our location struct is decodable from JSON. We do that by saying : decodable. That's it. And that's all it takes to make Xcode happy again. It now understands how to convert location from JSON into actual Swift structs, which is great. So that is locations.swift initializer right here, the init. But before we're done, I want to add one last property here to store whatever is the primary location. Whatever is the most important location, whatever should be shown in the most prominent thing when our app first runs. This is different from all the other properties we had so far because we have no idea at this time, as we're coding right now, what the primary location ought to be. What should be shown when our app first runs. So we can't just say it's the Highlands or it's the Smoky Mountains or whatever it happens to be. We can't do that. We can't do that at all. So we need to say at runtime, load the JSON and return back the first item at runtime when our code actually runs. So we can't say now, as we're coding the Swift, we can't say what it's going to be. So rather than having another constant property like this one, we're instead going to make a computed property. Which is, yes?
Night, Daddy.
Going to bed?
Yeah.
On for a hug.
Wait, who's watching this?
These folks right here are watching. You want to wave? Yeah. Good girl.
I can see that someone said happy birthday.
I know, because my birthday, isn't it? Yeah.
We don't have time for cake today, so tomorrow's cake.
Oh, I'm getting cake regardless. Maybe tonight and tomorrow.
No, Daddy, you don't know where it is.
I can smell cake a mile away. I've got a cake nose.
I'm not eating cake.
All right, off to bed, you Tara.
No.
Love you.
Can you move the chair?
Oh, sorry. How's that? All right,
Yeah.
off you go. Bye-bye. That's Lottie, not Sophie, by the way. Sophie's the bigger one. She actually does some stuff by herself. Anyway, properties. Yes, computed property. A property that has a value that's calculated at runtime when our code actually runs. And this means it can run some custom code to figure out what the correct value is to send back. And so we're going to add another property here. Below places, we're going to say var primary returns a location and send back places 0. So this is now var. It's variable. Its value might change over time. It clearly isn't going to change, but it might change. This is in difference to let, a constant. This will never change. But also notice how I've said places 0. Read the 0th item from our places array. And that actually returns the first item because Swift, like I think almost every other coding language out there, starts counting its arrays from index position 0. So places 0 is the first location. Places 1 is the second location. Places 10 is the 11th location. It's called off by 1. It's very, very common, but it starts from 0. So that returns back the first location in our array. And with that, we are done with the location struct and the locations class. But before we're done with this step, I want to actually use this somehow. Use all this work we've just done to have URL and data and decoding, yada, yada, yada. I want to use this somehow. And this means going back to our Trekker app.swift file and creating a new locations object here, which will in turn load the JSON from the bundle and let's use it. So here we're saying use our example location. I'm going to instead say create a new locations object which will load the JSON and send in the primary location from there, whatever is the first item in the array. And hopefully now we press Command R, our code should build and run. Let's find out. And we should, all being well, see, do it. Boom, the Highlands are back. Except now it's not hard-coded. This is coming from the JSON file in our bundle. It's a much, much nicer way of working. Data, information from your files should be stored outside of your code. Otherwise, you have to recompile your project, rebuild your project, make a tiny typo change. It'd be very, very slow and inefficient. Okay, that was a lot of code. I get that. So let's pause now and have another quiz. Now's a good time to remind you this is a charity stream. I'm sure Prathamesh can post once again the charity link. I am fundraising for a local charity. If you're able to, you don't have to, if you're able to, even $5 in their direction helps people who really need it. We're only 3 days before Christmas and it's a horrible, horrible time to be hard and down on your luck. So if you can, please donate to the charity. Anyway, let's have a look at our quiz. Our next quiz here. Quiz number 3. Are you ready? Reminder, please, please, please don't post the answers in the chat window. Right or wrong, post nothing in the chat window. Let folks who are watching later on have the full, fair chance to answer by themselves first. Here we go. Quiz number 3. Which of these could store a person's name? Is it int? Is it string? Is it double? Or is it view? Which would you use to store a person's name? Like Paul or like Lottie, who just ran off to bed. Have a little think. Pause if you want to. Bits is not listening to what I'm saying, apparently. Thanks, Bits. And there's Maxim. Come on, folks. Please don't post in the chat until folks have a chance to see the answer themselves, have a think about it. Can't be much clearer, honestly. The answer is string. And next question. Which of these could store the number 3.141? Is it int? Is it string? Is it double or is it view? bit, it's not a joke. It's just ruining it for everyone else. Just don't post the answers in the chat window, please. Which would store 3.141 int, string, double, or view. Have a little think. Posting the wrong answer is still not helpful, folks. Please post nothing in the chat window. Let folks come along and try themselves. The answer is, of course, double. Int holds whole numbers like 3. String holds text like hello world. And view holds SwiftUI layouts like VStack and images and similar. So double. And question 3, what does let signify? Is it a variable? Is it a constant? Is it a string? Or is it an array? A variable, a constant, a string, or an array. This comes from mathematics. Say let x equals 5, for example. And of course it is, thank you, Maxim and Yuri, it is a constant. It is a constant. A variable that cannot change, or a property that cannot change. And this is really, really helpful because it stops you changing it by accident. When you've got a real variable, you can modify it later on in your code if you want to, which isn't helpful because you might have screwed something up by accident, right? With a constant, if you try and change it, Swift will say, nope, I refuse to let you build your code. You cannot change constants. Constants are really, really helpful. There's another one. Swift uses exclamation mark to mean what? Is it this code might crash? This code is really important. This code should be executed quickly. And this code likes to shout. F-logic, you must make sure you add decodable after your location struct. Location : decodable, as Russell Gordon just said. So exclamation mark, what does it mean? This code might crash. This code is really important. This code should be executed quickly, or this code likes to shout. Of course, the answer is it might crash. Now, to be quite clear, some folks look at exclamation mark, aka the crash operator, and think this is making Swift unsafe. And it's not. Technically speaking, which is of course the best kind of correct, exclamation mark is still known as safe code. Unsafe code is code that might crash without you being aware it might crash. Exclamation mark is explicitly saying, I know or I believe firmly this is definitely safe. You might be wrong, but it's still safe to use exclamation marks from a language perspective. And that leads on to quiz number 4, which we'll tackle later on. Okay, on to the next step. Our app's coming together a little bit slowly now, I think. What we want to do now is add a tab bar across the bottom. This screen's basically done. I'm happy with this. If we add a tab bar across the bottom, though, the user can go to different parts of our application. And in SwiftUI, this is done with a new view type called tab view. And you then give the tab view all the views you want to show in these tabs. In our app here, this is best done inside our trekkerapp.swift file. And so you want to wrap the navigation view in tab view. Like that. Boom. Swift Fanatics asking here, if observable object was not added to locations class, what would happen? So our class here, we added this thing here, observable object. What would happen? If I take it away and press build, you'll see Xcode's like, yeah, great, brilliant. That works for now. But imminently, in less than 5-6 minutes, that'll be required. It's absolutely required for the next step we're going to go for. You'll see why in a second. Again, this is designed so SwiftUI can watch this class for changes. We know it's never going to change, but we still have to have this observable object in there for locations. It is required just shortly. Anyway, Yevgen asks a more advanced question, why your classes are not final. There's no need to be, really. I mean, you can make it final if you want to, but there's no need to be because this is more advanced, but Xcode enables whole module optimization by default, so you get the same result. There's no real difference there at all for that. Anyway, sticking with the beginner stuff. I don't want to scare off folks too much, you know. Anyway, we want to say here, this thing here, our tab view. Boom, we now have our navigation view inside a tab view. And you can, and basically should, also configure how each view looks inside the tab. How it looks inside the tab. Henry Kim, you've got a typo in your code. It's saying you're looking for your code is crashing there because you've got the wrong name. Anyway, tab views. Yes, you want to customize the way this tab looks on the screen, which means adding an icon and adding a label below it. Now, you can here use custom images if you want to, custom image or icon below your tab if you want to, but you can also draw on over 2,000 icons built right into iOS and macOS, tvOS, and watchOS. They're built right into these systems. And previously you saw in Content View that we can just do image followed by quotes Highlands and get that image from our asset catalog. But when you want to load an image from a system, one of the built-in system images, you say image system name some name. We can use that right here. I'm going to customize the tab item for our first tab, this navigation view here. I'm going to say it's got a tab item attached to it, which has the image with a system name, capital N, like that, being airplane.circle.fill. And the text of discover, like that. I'll press Command R to build and run. And all being well now in our code, you should see, boom, a little airplane circle fill icon at the bottom there. If you can't really zoom in on this thing, I don't think. But anyway, down there somewhere, you might be able to see it. Maybe, I'm not sure how it works. If you can zoom in on my screen, perhaps you'll see a little icon down there with the word discover beneath it. Now, what we're saying here is this thing has that icon. And there's no magic happening here. You know, iOS isn't reading the string and saying, oh, he wants an airplane with a filled circle around it, and then drawing an icon just for that. This is one of the many, again, 2,000 plus built-in system icon names. And if you want to get these for yourself, you can download SF Symbols from Apple. It's an Apple app, which is free. There's a link in the video description. I can paste it into the chat as well, which is a free app from Apple that lists all the symbols you can use inside your programs in the system image initializer here. And if I run SF Symbols on my Mac here, it'll have a little think, hopefully. Come on, where are you? Bouncing around the dock. Get to work. Boom. This is SF Symbols. There's the whole set of icons. And I can just go ahead and search in here for airplane. There we go. Airplane.circle.fill. And this way you can navigate through different categories of stuff to find, you know, nature or media, whatever, and find these things. And the wonderful thing is these are all vector. They scale up or down to match whatever size you want. They look great at various sizes. They also look great at various weights too. So you can see I have a regular weight here, but I might have chosen like a black weight, a super thick weight, or yeah, it's super thick now, or an ultra light weight. Give me skinny icons. They are available at multiple weights, all these weights here in other kinds of fonts as well. So see there's like a compact, rounded, and more. Many, many varieties for over 2,000 icons. It's really, really amazing. It's the standard way to include icons in your application. So check that out. So anyway, we added a tab bar so we can add more views to our app. And in this case, we're going to add a wholly different kind of view to this, which is, you want another treat? Come on. You're so hungry today. Always so hungry. Yeah. Anyway, a wholly different kind of our app. Oh, Jainam Shah has hit a problem, which is that the navigation bar turns yellow. There is a known bug in Xcode 12.3, which Apple have not fixed somehow, bafflingly. Well, often they get a yellow navigation bar. It's a known bug. I think it's to do with the way the GPU is being used. It's a bug. It's brand new in Xcode 12.3. It was not there in 12.2. Hopefully it'll be fixed real soon. Anyway, back to our code. There's our first tab here. This is one tab right here. That's our first Discover view right there. And what we want to do now is add a second SwiftUI view here. And this is going to show a map, a whole other map they can navigate around and see places they can visit visually. So I'll press Command N, make a new file. No, clear off, dog. You get any more treats do you want? Come on, go away. Honestly, go away. You, out. Come on, out, 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 out. Sorry, the dog is now bothering me for snacks. Command N to try and make a new file without the dog being involved. There we go. And what we're going to do in here is choose a new SwiftUI view, like this. And choose next. I'll call this thing World View. Show me the whole world. And press Create. There we go. And this is a separate view in our code. And so it'll have its own preview, have its own layout code, the original text hello world's back again. And we want to modify this to have a map. Now, making this view means meeting some really important SwiftUI features, most important of which is called a property wrapper. Property wrappers. And these are special annotations you can put into your code that enable new, more advanced functionality. And they are used extensively in SwiftUI, again and again and again. And the reason we need them is because SwiftUI needs to know how to create and how to manage data. And for example, here, what's running here? I've got my Xcode. Where's my simulator gone? SF symbols can just go away now. What else do I have? Keynote can go away. Somewhere around here. There we go. Our data here, this thing here. As we're using the application, this thing will be modified. It'll change over time to reflect the current configuration of the program. What tab are we looking at? What button was tapped? What text was typed into a text box and similar? All these things will change over time. As a result, SwiftUI wants to know how that's being stored. It wants to know, hey, you want to put a map on there? Fine, but tell me where the map should be looking. And let me update that value as the user moves the map. As they're sort of pinching or swiping around the map, store that data somewhere. So all the current live configuration data has to be stored somewhere in our data. And SwiftUI calls all this data state. What is the live modifiable data that stores the exact current configuration of our application? And SwiftUI is really insistent. It wants to know exactly when and where any kind of program state is being used. So it can make sure the memory is created for it and kept alive. So it isn't, destroyed by accident in the future. It'll keep alive all our state for us automatically. So we're going to put this into action right now with Worldview by adding a map to it. So let's get rid of this thing. I'm going to start by bringing in a new framework. You can see here we're importing SwiftUI, which means bring in all the SwiftUI functionality required to make our layouts. Fine. But here we want a map. And maps aren't controlled by SwiftUI. They belong to a separate piece of iOS called MapKit. So we're going to say above import SwiftUI, import MapKit. This is a third convention. Put your imports in alphabetical order. You don't have to. You can do it like that. But that'll give me an eye twitch. Please don't do that. Particularly if you have, 5 or 6 imports, having them alphabetically is a nice, simple way to make your life easier. And now we want to show our map. But again, this has to know what to show. We'll tell it ahead of time, here is the initial region to show. Like what the center is, and also how zoomed in or out of the map we are. This is done with a fairly long piece of code. We say a new property, let region be a new MK coordinate region. MK is MapKit. MK, a MapKit coordinate region. And this takes various values. One is the center. Where is the map centered? What's the center point of the map in latitude, longitude coordinates? This has a new value, which is a CL location coordinate 2D. CL here stands for core location, one of Apple's many parts of iOS designed to handle location. Where is someone in the world? CL core location. There's a core location, location coordinate, 2D. A 2D coordinate, latitude and longitude. There's no height in this, no altitude. So a 2D location coordinate. And this wants to know what is your initial latitude and initial longitude. For me, initial latitude will be 51.507222. And longitude will be minus 0.1275. That is the centre of the City of London in the UK. That's where we want the map to centre on London to begin with. Of course, it's your program, centre wherever you want to, but I'm doing London. It also wants to know what is the span of the map. How much around that do you want to show? This creates a zoom level. How much of the map do you want to show? Again, in latitude and longitude. So we'll say our span is going to be an MK coordinate span. Again, MK is map kit. Latitude delta, I'll do 40 degrees. Longitude, 40 degrees. And this will start our centre on London, but at sort of a middling level of zoom. You can see, Europe. You can see where you are. You'll pan around and see the rest of the world fairly easily. You're not like laser focused on Buckingham Palace, which would be a very boring way to find Tokyo or Kyoto, sorry. So the user can get around fairly easily from there. This is our starting region. Start the map there, please. And now in our body, we can replace this text with a map with a coordinate region of region. And I'll give this thing the navigation title of locations. Daniel asks, there we go. Could you also use your current position? Yes, you can. It does require more work because you've got to ask for permission to read location first, which is obviously more difficult. So I'm not doing it here. This is a simple, easy way to get us started. Okay, so we now have our region and we made a map to show it, but as you can see, Xcode's unhappy. It's got this big error here. It does not like it. What it means is, telling the map where to start matters. It's got to know what's the initial region to show. But the map's movable. They can pinch around. They can swipe around to go and explore Asia or South America or somewhere else after London. And as a result, SwiftUI wants to know how to update the property. And that isn't possible right now because this thing is a constant. We've said, here's our constant region to show. So SwiftUI has no way to update the region over time. As the user swipes around, it cannot change. To fix this, we've got to make 3 changes. First, we'll make this region here variable, so it can change over time. Second, we're going to make it really, really clear to SwiftUI. We've got to explicitly tell it this is live program state. It's going to change over time. It's got to be kept alive at all costs for this to work. And this is done using a property wrapper. We say at state var region. And this @ sign signals this is a property wrapper. There are a handful of exceptions, but nearly always in SwiftUI, at something or other is a property wrapper. And this is what triggers a special behavior. We're giving control of the state over to SwiftUI to handle. When this view is running, it can be destroyed. We don't care. Recreate it 1,000 times. We just don't care. Keep this data alive. It matters. Look after it for me, please. And the final change is we've got to tell our map that it should read and write this region value, which is done by using a 2-way binding. Now, a 1-way binding could mean read this value, but don't write it. Or write this value, but don't read it. Write only or read only. A 2-way binding means read this value to start with. This is your initial value. But if we make changes to it as they pinch and swipe around the view, also update the value to reflect those changes. And in Swift, that's done using the $sign, dollar region like that. And again, this dollar syntax here makes it really clear. It stands out as bringing with it special behavior. There's now a 2-way binding for our map thing. Using that very, very kind donation. Thank you so much. Folks, if you can, please post to the charity link, which we'll post again, hopefully as a comment if all being well. One of the kind folks help me out there. There's a charity I'm doing this whole live stream for. Please give your donations to them. They need it much, much more than I do, or my dogs in their treat collection do. So $1 makes a two-way binding. And that will actually compile now. Now, we're going to customize this some more in just a minute, but not just yet. First things first, I want to go ahead and add this to our tab view so we can see it actually working. So back in trekkerapp.swift, here we have our tab view. This is our first tab here, and a second tab below it, another navigation view with a world view inside, and a tab item being image system name of star.fill, like that, and text of locations. Boom. So show that map in its own tab in our tab view. Thank you, Prathamesh. Very kind of you. That's the donation link, folks. Just giving /fundraising/2 straws. Anyway, go ahead and press Command R to build and run. And we should now see our map working live on the screen. Broderick says they can't find $region in the scope. That usually happens because you've forgotten to add the @state property wrapper before your property. Anyway, here we now have locations, or being well, a map. Centered on London, we can just pan around and find other countries just fine. And of course, if you want to pinch, you can hold down the Option key and then click and drag like that to simulate 2 fingers and just swipe around. There's our whole map looking real nice. Okay, so now our map is working good, which is great. Of course, what we really want to do is send in all our locations so we can see them on the map. But we don't want to recreate those locations. We already loaded them, got that JSON out, there's a string, read it through, convert to data, converted all that work already once. We don't want to repeat that again and again and again. We want to do it exactly once. And we already have this locations class to do all that work for us here. What we want to do is use this object everywhere, right? And SwiftUI is done using a special system called the environment. And it lets us create and share objects everywhere in our app, which is more efficient than repeatedly creating them again and again and again everywhere we need them. This takes some more property wrappers. I mean, SwiftUI loves property wrappers. It takes one to create the object and another one to use the object. Now, right now here in trekkerapp.swift, we want to create a locations object, this thing here, only once, when our app starts, and keep it alive the entire time. Don't make it twice or 5 times or 100 times. Make it once and keep it alive the entire time. But right now, we do that right here on my line 16. We pass it directly into the location, into the content view. So it's not being stored anywhere else. We can't give the same thing to our world view to show on the screen. What we're going to do is take out this value here. Take the whole thing out. And instead, put it into a property up here for our app struct. This property is called var locations equals locations. Make a locations object here that belongs to the whole app once. And now we can pass that into our content view, locations.primary. So create it once up on line 12 and pass it into content view. Pass it anywhere else we want. Now, when you make objects like this, to make sure it stays alive, just like we had @state for our worldview, the @state is good for handling any kind of struct, which is like our location or our region or something like that. Any kind of simple value that's local to you is great for @state. But for complex things like class, SwiftUI has a different property wrapper, which is @state object. So when you have a class that conforms to observable object, that thing we had before, you want to use @state object. Other times, @state. And this means I'm going to create this thing here. I want SwiftUI to own it. keep it alive for me. And this is where the observable object becomes required. If I had gone to locations and removed the observable object, Swift would be unhappy. This thing requires locations conform to observable object. It is required that Swift be able to watch state objects for changes. Even though it's not changing, it is required to have that observable object text after locations. Otherwise, it simply will not build your code. Even though nothing's changing, it is required. So now we make the locations once and send the primary location directly into the content view. And now for the important part. We can put that locations object into the environment. So any part of our app that wants to read our locations class can do so. Just reuse the same one that was already loaded. Don't reload the JSON again and again and again. We already did that once. Just use those shared values. That's done with a special modifier we're going to put onto our tab view. The tab view starts here, ends here. We'll add a modifier here called .environment object. And all you got to do is pass in your object, locations. Pass it on in. Post that object into the environment. So anyone who wants to read it can now read it. It's not automatically everywhere. You've got to ask for it, but at least it's available for when you want it. And so now, back in our world view, we can say, yeah, I want the locations here, please. I want to know what the locations are. This is a third property wrapper at environment object. Var locations is a locations object, like that. And that's enough. SwiftUI can see we're expecting to have a locations object being passed in the environment somewhere. So when this view is made, it'd look at the environment, find the first locations class it can, and assign it to be our local property, locations, ready for us to use. And if somehow there is no object in there that's a locations class, bang, your app crashes. Do not do that. It's a programmer error. There's no way of catching that. Just don't do it. Make sure there's a locations object in the environment, otherwise it will not work. Just briefly, by the way, if you are enjoying this video, if you're learning something from the stream, please hit the like button. It helps other folks discover the video. Helps me, makes me want to do more videos, helps you, helps everyone. Hit the like button if you'd be so kind, and of course you can subscribe if you want to. You really like it. Anyway, we've now said that our worldview wants access to that shared locations object, which has got all our JSON loaded, ready to use. And again, if it's not in the environment, your app will just crash. And now we can modify our map. We can say this thing here, our map, has some annotation items, things we want to draw onto the screen. So the coordinate region is that starting region, great. But the annotation items is locations.places. And when you do that, you can provide an opening brace and give it some code to run for every one of the locations it finds. So it'll give us a location coming in. If I hide this left-hand bar here, you might see it more clearly. There we go. We want to say, for every one of the locations coming in, what do you want to do? How do you want to draw this location onto the screen? So this will be the Highlands, and then it'll be Verona, then it'll be Kyoto or Taj Mahal again and again and again. It'll run this code again and again and again, once for each item in the places array, give us that current value in location, ready for us to work with. And what do we want to do? Well, we want to add an annotation, which is a graphic on the map showing the flag or a pin or something else on the map to show there's something here that's important. So we'll say there is a map annotation, a new kind of data type designed to draw things on the screen. This thing wants to know a coordinate and some content. The coordinate, again, you can see is a CL location coordinate 2D. What's the latitude and longitude of the annotation? So my coordinate will be CL location coordinate 2D. Boom. Latitude, location dot latitude. attitude, longitude, location dot longitude. Like that. The content is what should be shown for this annotation. What do you actually want to draw on the screen for the annotation? And for us, I want to draw little flags. The UK flag for Scotland, the little Japanese flag for Tokyo, and similar. So we can say there's an image of location.country, which is resizable, so it can become bigger or smaller. I'll use a new modifier called corner radius to round the edges of the corners a little bit, so it's not a square anymore, it's like a rounded rect. I'll use 10 points of rounding. I'll then give this thing an exact size. Do not draw the flag at its natural size, draw it at a particular size, so it isn't, massive on the screen. I'll say it has a frame width of 80, height of 40. So a good size flag, but not too big. And finally, another new modifier. Give it a shadow with a radius of 3 points. So a very gentle shadow behind our flags. This is really helpful because some flags, like the Japanese flag, are pure white on the outside, and it is hard to see where the sort of flag ends as you hit the background around it. So a very gentle shadow around it will help pick the flags off the map very, very nicely. The code is all correct, but once again, Xcode is complaining in a good way. I want Xcode to tell me what I'm getting wrong. It's saying, location must have identifiable. Okay, we know this. This is just like when we said content view is a view. Locations is observable. Location is decodable. Location now must also be, as Xcode said, identifiable. So we'll say, okay, location, you're decodable and you are, identifiable. And this allows SwiftUI to use these things drawn again and again and again in a loop, to draw them all at the same time. So it knows what makes each location unique. This identifier is unique for every value. So it's looking for that value there to know how to make unique locations. With that tiny change, this thing is identifiable. All being well, our code should now build. Let's find out. Boom. Build succeeded. Let's go ahead and press Command R and see how it looks. So our first tab and second tab, locations. There we go. There's the UK, there's Italy, down here's Egypt, we have India, here's Malaysia. So you can see these all look great now. The little shadow just helps pull off the edge of the background behind it. Really, really mild stuff. Okay, that's much better. But wouldn't it be nice if you could tap on Egypt and see what amazing sight there is to see in Egypt? That's what you want to do, right? You want to sort of navigate, find the map, and then press that and go through and see the result. We can do that with another kind of view called a navigation link to say when this thing is tapped, when this whole image thing here is tapped, what do you want to show? Mohammed, yes, Malaysia's on the map. I love Malaysia. My brother lived in KL for years, and actually Penang's in the app because I love Penang. Penang's a beautiful, beautiful city. Anyway, there's an image here, and I want to say, actually, if you press the image, show that location. Now, we already made our content view, this thing here. This thing knows how to be given a single location and how to show this location on the screen. That's what this single view content view is good at. Give me a location, boom, I will show it in a scroll view with a picture and done. It's really good at that. And so we can make a navigation link with a content view as its destination. Show this on the screen. So we'll say before our image here, let's hide the left-hand bar here to make a bit more space. There is a navigation link with a destination being a content view. Or destination even, a content view. Now remember, content view needs to know what location it should show. But we already have that. It's right here. Here's the location for the current annotation. What do you want to do with it? So we can say our destination is content view, location is our location. Navigation link also wants to know what is tappable. Is it a button with some text? Is it an icon? Is it a flag? In our case, it is a flag. And so we'll put the whole image inside the navigation link like that. When you tap that picture, that flag, go to the content view for the current location like that. Let's press Command R and see how that looks. Let's have a look. Exciting. Okay, here's locations. Here's Italy. I'll press on that. Boom. Verona. Beautiful. I love Verona so much. Amazing place. Amazing opera house. There's Abu Simbel. Or over here was Taj Mahal. It all works just fantastically. Here's Penang. Love Penang. Great Laksa. Here's Kyoto. Such a beautiful, beautiful city. Amazing. So you can see we can now navigate around and reuse our location view, our content view, sorry, again and again and again, straight from the world map, making a very nice application now. Okay, let's pause for a second. We're now like 2 hours and 40 minutes in. You folks have got great stamina. Well done. I haven't even touched my water yet. Watch, have a little sip. The question here from Basili, I guess, Kowalski, how can we modify navigation link to change direction or animation? I'm afraid you can't at this time. There's not a lot of extra customization in that right now. If you were using UIKit, you could customize the transition between one view and another view. You cannot currently in SwiftUI. I know they'd like to enable that, but it's currently not possible. Particularly with direction, be careful with that because the system is designed to adapt itself to different kinds of locales. When you have, we had like padding for top and bottom or horizontal, you can also have leading and trailing, the left and right edge. But you don't say left and right, you say leading and trailing because left and right will flip around in languages like Arabic, which are right to left languages. So it'll become leading will be the right side and trailing will be the left side, so it flips it around. So direction's a complicated one. You want to adapt automatically by leaving the default behavior. Anyway, let's do a quiz. Let's do another quiz. Let's see how we get on. This is like the last quiz, I think. We'll see how we get on. All right, so quiz number 4. Are you ready? Again. Don't post the answers. Don't be that person posting the answers. I don't care if you're right or wrong. Just don't post the answers in the chat. Give folks who are watching this tomorrow, next month, next year, whenever, the chance to think about it first, come to their own conclusions. Do not post the answers in the chat. Good grief. Quiz number 4. Where does SwiftUI's map view come from? Is it SwiftUI? Is it MapUI? Is it MapView or is it MapKit? Where does the map view come from? Is it SwiftUI? Is it MapUI? Is it MapView or is it MapKit? Have a little think. If you want to, pause the video. Take your time. The answer is, of course, MapKit. It is separate from SwiftUI. There are stacks and stacks of these things called frameworks built into iOS. We use SwiftUI here. MapKit's available. There's WebKit for doing web content using Safari. There is SpriteKit for doing high-performance 2D graphics. There's SceneKit for doing high-performance 3D graphics. There's RealityKit for doing 3D AR graphics and so forth. There are stacks and stacks of kits you can just pull on and use, and MapKit is one of them. Which Apple app shows system icon names? Is it SF symbols? Is it Apple symbols? Is it Xcode symbols? Or is it symbol symbols? Which Apple app, which is free to download and highly recommended, shows system icon names? Again, you can get this from the video description, folks. Go there and find the app link there and give it a try. And it's great for just filtering through and finding stuff. So yes, it is SF symbols. Next up, what does $sum value mean in Swift? A $sign with a property name after it, what does it mean? Is it an expensive value? Is it a system value? Is it a two-way binding or an observable object? Is it an expensive value or system value or two-way binding or observable object? Which of these does $sum value mean? Have a little think. Pause the video if you want, and have a go. The answer is, but hurry up. Boom. It is a two-way binding, which means it'll read the value at first to show it on the screen, whether it's some text being input or a map region. but it'll also write the value back to the property as it changes to store the state somewhere safe. Next up, where does SwiftUI store its shared values? Shared values. Is it in its pockets? Is it in the environment? Is it in the views or in arrays? Where does SwiftUI store app-wide shared values? Have a little think. Thanks for coming, Russell. Great to have you here. The answer is, of course, the environment. Okay. It is now, good grief, 7:42 already. We're almost through our 3 hours completely. Do you have time for more, folks? I could wrap up now or go another sort of 20 minutes or so till 8 o'clock my time. Let me know if you want me to do a bit more, if you've had enough SwiftUI for the time being. Now you can write that in the chat if you want to, otherwise I'll have no idea what you mean. Would you like some more SwiftUI, a little bit more, one last for you, or have you had enough for the time being? I'm going to drink some water in the meantime. Prathamesh, yes, it could be confused, but I have not covered that here. This is an absolute beginner tutorial. I'm not going to assume unknown knowledge. Henry wants some cake. No, it's my birthday. I get the cake, and apparently my kid gets cake too. So there is no cake for the attendees. Otherwise, there'd be no cake for anybody. You get little crumbs each at this number of people here right now. Okay, it looks like the verdict is to have some more. So let's try something a bit more challenging, which is the last tab in our layout, which is to handle this JSON file here, tips.json. This has a question answer layout. We want to have, how to pay or when to pay or who'll be in my group or about this app or whatever. We want these tabs, these questions in a nice layout on our screen. And so this follows a very similar layout to what we had before. Martin, that's very gracious. Thank you so much. That's extra treats for my dog. Folks, if you want to contribute to the charity, please use the charity giving link. The money goes straight to them. I see none of it. It goes straight to them. Any money here goes to my dogs for dog treats, I'm afraid. But charity link, which I'm sure Prathamesh will post again because he's so awesome at this, goes straight to the charity to help folks who are experiencing homelessness or have learning difficulties or are leaving prison and more. So please give to the charity as opposed to me. Thank you, Prathamesh. You're awesome. Thank you so much. Okay, so we're going to add a final view just real fast in the last sort of 15 minutes or so to add a final view to store tips. So this is going to be very, very similar to how we handled locations. We had this location struct over here, which was decodable. We listed out its properties and then worked forward from there. But there's a difference this time. You'll see. First, make a new file, Command N or File, New File, if you've got the menu bar approach, and choose Swift File. Then press Next. And for the file here, I'm going to give this thing the name tip. This is going to hold one tip from our JSON file. From tips.json, it'll hold one tip. Just like location held one location, this is one tip. So I'll create that. And we'll say there's a new struct called tip, which is decodable, just like we had with location. And in our tips file, it's got a very particular format. You can see there is a text string first, where to go. That's an easy one. We'll do let text be a string. Easy. But the next one is more challenging. Children, the things that answer that question is an array of text. Here, an array. But this itself has its own name, text. And this is done in a very particular way because of the way SwiftUI works. SwiftUI wants this data in a really, really particular format. It wants the children to be an array of tips. So we have tip, the main struct, and the children of that is an array of tips. And if you remember, when we had our location example, we had an example location inside the main location struct. and Xcode complained. You've got a recursive thing here. Locations have, locations have, locations have, locations, infinitely big, impossible struct. But arrays are safe. Arrays can be empty. There can be no tips inside here. So it's safe to say an array of tip is inside tips. There's no recursive infinite loop here. You can break the chain by saying, my array is empty. There are no children. But there's one more thing. And this is one of the things that folks find really hard about learning Swift. And if you follow one of my online courses that are completely free, like the 100 Days of SwiftUI, which hopefully Prathamesh can link to. Thank you so much, Prathamesh. The thing you're about to encounter is called optionality, which means this data might be there or might not be there. In this case, you can see this text here has children with this object here. This text does not have any children, just some text all by itself. Again, this text here has children. This child one does not. Again, text here has children. This child one does not. And in Swift, we represent optionality. This might have children. This might not have children using a question mark. That's it. Might be there, might not be there. And the reason this exists is because this complex layout we're going to do can actually be multi-level. You can have children, then grandchildren, then great-grandchildren, great-great-grandchildren, big line of stuff going down the way if you really wanted to, but it's not going to happen here. Only one thing, parent and child. So that's going to hold one tip, the title plus its answer as a child to the text, like that. And so we're going to show this inside a SwiftUI view. I'll press Command N, or again, File, New File. Change Swift file to be a SwiftUI view. Prathamesh, if you could link to the 100 Days of Swift, please. SwiftUI, sorry, 100 Days of SwiftUI, that'd be helpful because that'll let folks find the free online courses full of videos and quizzes and much, much more, all online, all free of charge. Go and check it out. Thank you. I'm sorry, I'm making you post links. It's very kind of you. A SwiftUI view here, and choose Next. And I'm going to call this thing the Tips view. A view just for showing tips from our JSON, like this. Now, this thing is going to have inside it, it's going to be able to show, I'm not quite sure why Prashant, but I can't show links from other people. I don't know why. It doesn't like it very much. It seems fine with Prathamesh posting it, because he posts as a moderator, he can do it, but other folks, I get an error every time. I don't know why. You know, YouTube, who knows? This thing is going to have an array of tips right here. Here's the array of tips you want to load. And if you remember, this thing has to be loaded from somewhere. It has to be loaded from our JSON. Now, we're not going to make a whole external class this time. That's a lot of extra work just doing this little bit of code. And we're not passing it around anywhere else. It only exists in this one file. And so we can actually add an initializer directly inside our tips view. When this thing is being made, what do you want to do? So it's going to be, I'm going to actually copy and paste it because it's almost exactly the same code. So in locations.swift, this init, just grab that. Just take that whole init, Command C to your clipboard, go back to tips view, and just paste it on in there. You know? There you go. It's the almost same code, right? Except now we're not loading locations.json, we're loading tips.json. We're not storing it in places, we're storing it in tips. And we're not decoding an array of location, we're decoding an array of tip. Just changing it to match the other thing. All the same warnings apply. Crash operator here, crash operator here, crash operator here. There are nicer ways of doing this for more advanced work here, but we're not using it here because it's nice and simple for now. And now we can fill in our body for our list. Now, this thing here in our tips, we're going to say, I want to have a list. And lists form nice tables of data in iOS. We'll say this thing is a list over our tips. And for each tip coming in, give me that value. And any code here can now read the current tip and decide what to do with it. So we can work with it. We can say, has this got any children? If it has, it means it's a question. Let's show it with a little icon next to it, a bubble quote with a larger font, whatever. If it isn't, show it in regular text. And SwiftUI actually has a dedicated view type for showing icon plus text combinations. You can do image, of course you can. You can do text, of course you can. But if you want icon plus text neatly aligned, you can use a label. A label. Our label will be our tips text with the system image of quote.bubble. Again, that's a quote I've taken an image I've taken directly from SF Symbols to work with. Now we want to show this only if this has children. This is a top level question with an answer attached to it. So we'll say if tip.children is not equal to nil. And nil is a special value. It means this is an optional that has nothing inside. Remember, when we defined tip, we said it's got a children array of tip, question mark. It might have an array of tips as children, but it might also have nothing at all. It might be a child itself with no children of its own. So it could be nil, it could be missing, blank, zip. And so we're checking for that here. If we have children, then show our nice icon plus tip text. And we can even say .font, .headline, a slightly bolder, bigger font to work with. And that will adjust both the icon and the text at the same time, uniformly, and position them correctly relative to each other. But else, if we have no children, this is the answer. It's a small thing. Just show a text of tip.text. There's an answer, a small thing. And also say, like elsewhere, our list has a navigation title of tips. Now it's angry at me here because we have an array of tips coming in and we want to show them all in different rows in our table. The problem is SwiftUI doesn't like having dynamic data. It wants to know what makes each value unique. The reason is, potentially, we aren't doing it here, but potentially, we could change our tips array over time. We could add a new one, or delete one. If they swipe to delete or whatever, could remove them or add them or move them around or whatever. They could change over time. And SwiftUI wants to know, how can I be sure each item is unique? What is it about each tip that makes it unique? And when we had that in our map in worldview.swift, this thing here has annotation items. What are the places being used with this map? And this complained, if you remember. It said, okay, if you want to do that, fine, you can use places here, an array of places, but you've got to tell me what makes these unique. And we said at the time, we'll make them identifiable. And as long as you have a property called ID, you can do that. Because Swift will say, identifiable's fine. I'll use the ID property automatically. But our tip does not have an ID. There's no unique ID here. Fortunately, the text is unique. The text string in every question answer is different. So we can say, actually, you want to know how to identify each item uniquely? Fine. The ID for this is \text. This is called a Swift key path. What it means is read the text property from each tip and use that as the unique identifier. That will help us work. And you can see now the error's gone away. So I'll press Command B to build our code. What we want to do now, of course, that all compiles cleanly, is make sure this new view, tips view, is included in our tab view over in trekkerapp.swift down here. Here's our first two tabs. we'll add another one below it. We'll say there's a navigation view here. Inside that is a tips view. We'll then customize this with .tab item, image, system name, of list.bullet, and text of tips, like that. Show the tips as a third tab in our tab view. Let's press Command R and see how that looks. Come on. So there's our main tab, our locations tab, and now our tips tab. And there's a label with a quote bubble and then where to go in bold next to it. Now, we can't see the answers, but this is where SwiftUI's very careful structuring of data becomes beautiful. Because in tips view here, we can say, this is the tips we want our items to come from. This is our text. What we want to do is tell it what the children are. What identifies the children for each tip. And we can say, actually our children is \.children, which means another Swift key path, use the children property of our object as the children. If you remember, we had our tips file here. Children is where we store the child tips, the answers for our thing, our questions. And now if we build again and press Command R to run it, you'll see it changes quite dramatically now. Come on, you can do it. Tips, boom. Now these little disclosure arrows now. When you press on that, out slides answers. It understands the answers belong to each question like that. Really, really nice. You get so much for free here. The question here from Chris Yo. In a very contrived situation, what would happen in a case where you have two tips with the same text? Would you get a crash? No, you would not get a crash. In this case, if you had multiple tips with the same text for some reason, nothing would happen. It would look fine, right? Because we're not adding and removing things. If you imagine we had a list of 5 items, hello, 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 right? 5 items, 5 hellos. And we said, okay, remove the second hello. The before state was hello, 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 hello. The after state is hello, 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 hello. You're missing one hello. But SwiftUI can't tell which hello has been removed. Was it the first one, second one, third one, fifth one, whatever? It doesn't know. And so it'll animate the removal or the insertion or the moving of stuff wrongly. You'll get a bad animation almost certainly. It won't know what has changed. It'll take a guess and probably get it wrong. So it won't crash. You'll just get wonky behavior. It won't look quite right. Prathamesh asks, when you say tab item for stuff in Tracker app here, can you use a label? Yes, you can. I'm using image and text instead because at the time I hadn't introduced label. I had introduced image and text, but you can absolutely have label, discover, system name, system icon, sorry, airplane, circle, fill if you want to, using label rather than image and text. That works great too. Prithif asks, can you customize the UI? I'm guessing Prithif means can you customize the sort of disclosure arrow thing? No, you can't really. There's not a lot you can do with that, sadly. We are stuck with it. Anyway, so that now gives us our third thing, loading those tips in. And it's now 8 o'clock. I had planned to go till 8 o'clock. That's been 3 hours solid of streaming on my birthday for charity. I hope if you can donate to my cause on Just Giving, which hopefully, Prathamesh, one last time, please post a link into the chat window. I hope you can donate even a few dollars there, $2 or $3. Really, really helps. I'm doing this on my birthday because I want to help raise money for an important cause, helping people in a very hard time of year, in a very hard situation in life. Please, you can donate. They're local to me in my city. They do amazing, amazing work. So please, you can donate to the charity. I hope also you've learned something. Thank you so much for coming along. You've been a wonderful audience, lots of great questions. If you're watching later, I hope you've read the questions and learned something from them. These folks have been wonderful coming here and helping out. Thank you for coming along, being a great audience. I hope you enjoyed it. We've made something new. I will post this finished code on GitHub and link it back to the description for this video so you can see it later on and download it from there on GitHub. If you have questions later on, I am 2straws on Twitter, TWO Straws. You're welcome to follow me and ask questions there. I believe somewhere earlier in the chat, Prathamesh very kindly posted a link to the Hacking with Swift Slack, where you can find out more information and ask questions there too if you want to. Is that it? That's it. Stuff said we've raised over £1,000 now. That's absolutely amazing. Thank you so much for your support. It's really, really generous. I'm glad to have hung out with you for a while, had to hopefully answer some of your questions, give you some ideas of things to try in SwiftUI, build a full app with you, but also raise money for a really, really important cause. Thank you so much for coming along. Thank you for all the very generous birthday wishes. It's been a real pleasure, and I hope to see you online on Twitter or Slack or somewhere else. Thank you so much for coming. Take care, folks. Bye.